Good afternoon, everyone. This is Vishnu Vardhan, and I welcome you all to IITISoC 2021 final presentation round. IITISoC introduces the participants to software development and open source, where the participants work on various open source projects under the mentorship of experienced developers. This year's IITISoC is the result of the collaboration of the Cynaptics Club, the Programming Club, and the Google Developer Student Club. This is a month-long learning curve with more than 160 participants and over 40 projects being developed. This is the final presentation round in artificial intelligence and machine learning domain. IITISoC is not just only about coding, but also involves an overall development of the management skills of the participants. Today with us, we have our ever-supporting alumni to preside over this final presentation round. Now, I would like to take this opportunity to introduce our distinguished judges. Our first panelist is Mr. Aditya Abhiram, who was a former head of the Cynaptics Club and also a two-time GSOC scholar. Along with this, he was a tutor for Google Explore Machine Learning. Moving on to our second panelist, Mr. Nemath Ahmed. He was the technical lead for the ESL and also a youth delegate under the Indian Youth Delegation 2019. He was a guest researcher and research assistant at various esteemed universities. Our third panelist is Mr. Shavez Malick. He was the former head of the Electronics Club. He was a founding member of the Cynaptics Club. Along with this, he was a facilitator for Google Explore Machine Learning. Now going to our final and fourth panelist, Mr. Suyash Bhutara. He was also a founding member of the Cynaptics Club. He held a senior position in the Electronics Club. Along with this, he represented IITI in various technical competitions. We are all thankful for your presence. Before moving on to the presentations of the project, I would like to inform the format of this event. The teams will be called upon one after another to present, after which there will be a Q&A session by the panelists. Also, the audience can type their questions in the Q&A section of the chat box. Today, we have a total of 7 teams in the AI and ML division with us today. So let's begin with the first team, ML3, with the project on news article summarizer. ML3, you have the stage. Team ML3, you can start your presentation.
Yes. Hello everyone. Am I audible?
Yes, you're audible.
Thank you. Good evening everyone. This is Shavez. Today we are going to present our IITISoC project, News Article Summary. The main aim of our project is to develop an effective end-to-end solution which accepts informative articles in common language and summarizes them with a proper headline in English. Further, if the user have any questions regarding the article, we will be able to answer them by our project. Our entire project is divided into 4 tasks. Task 1, translation. Task 2, summarization. Task 3, heading generation. And task 4, question answers. Approach to the problem. We will take an article as input. If the article is in English, we will proceed on to the next task. If it is in Turkish or Russian, we will translate it to English and then we will be proceeding to the next step. Aside from this, our project does not support any other languages. We will move on to the summary and finally headline generation. Once the translation process is completed, the summary of the article and the heading is printed as the final output. At last, if the user have any questions related to the article, we will be printing out the answer. Transformers. Here, our entire project is built on transformers architecture. The advantage of using transformer models is that they are non-sequential and avoid recursion, which saves training time and reduces performance drop due to long dependencies. Additionally, owing to its parallelization method, transformers makes it easy to work on large inputs. Hence, we prefer transformers. Task 1. Translation. For the translation, we have used a WMT16 dataset which accepts various languages for translation. And these are the two models we have taken from the Hugging Face for translation of Turkish to English and Russian to English. Fine-tuning. Fine-tuning is a way of applying or utilizing transfer learning. Typically, fine-tuning is a process that takes a model that has already been trained for one given task and then tunes the model to make it perform a second similar task. This enhances the performance and increases the accuracy of the model. Fine-tuning for Turkish to English model. This was done for 2 epochs, and the average training time per epoch is 34 minutes. The training accuracy stood at 99%, whereas validation accuracy came to be 98.3%. Fine-tuning for Russian to English model. This was done for 1 epoch, and the average training time per epoch is 273 minutes. The training accuracy came to be 97.8%, whereas validation accuracy stood at 98.5%. After completion of translation, we will be moving to summarization task. Here, the CNN Daily Mail dataset and the Facebook by Bath-based model are used to train this task. This entire procedure is built on the transformer architecture, which is ideal for conditional generation jobs. Here, we have chosen Bath model over T5 because Bath model can accept a maximum input length up to 1024 characters, whereas T5 can accept a maximum input length of 512 characters only. And also for the CNN Daily Mail dataset, the row score is more for the Bath compared to T5, and Pegasus has a similar row score compared to the Bath, but the time taken is high in Pegasus. Hence, we have considered Bath model for summarization task. Next, task 3. Fine-tuning our summarization task. This was done for 3 epochs, and the average training time per epoch is 21 minutes. The training accuracy came to be 97.8%. Task 3. Headline generation. For the headline generation, we have taken T5 base model and the articles1.csv dataset from the casual side. Fine-tuning. This was done for 3 epochs, and the average training time per epoch is 23 minutes. There is no training loss for this model, which suggests that the output is very efficient. And the similarity score stood at 66.66%, which is calculated on 20 examples from articles1.csv datasets. Over to you, Shiva.
Task 4. Answering questions. A pre-trained but large uncased whole word masking fine-tuned squad model is used to train the question and answer task for its better accuracy and detailed answers. In this task, we compare the following models. The first model has a high FN score of 93.15%, but the second model has an FN score of 88.5%, whereas for the third and fourth model, it is 79.5 and 86.9% respectively. Here, in order to compare these 4 models, we have taken 2 articles. For article 1, these are some sample questions and the right solutions. And these are the answers that we got for our 4 models. Similarly, these are example questions and respective correct answers for article 2 and answers we got for our models. After a thorough comparison, we found that first model gave a very detailed and efficient answers. The answers given by second model were also detailed, but some of them were wrong, whereas third one gave a very short and less accurate answers. Fourth one printed less detailed and wrong answers. So, on a whole, first one is preferred. Next, assembling all the trained models in a Python code. Here, we will be taking an input article, splitting into a list of sentences having not more than 500 characters. After that, we will be translating it into English. Before summarization, we splitted the translated article into 5 or 6 sentences and then sent to summarize. We followed the same procedure for headline generation. Then comes our question and answering task. Here, if the user has any questions, we will be printing out the answer, else the program ends. Flowchart of our project. First, taking input article from the user, then translation into English, next printing headline and summary of article in English, and then ask the user if he or she has any questions. If yes, takes in the question and prints out correct answer. If no, the program ends. Thank you.
I request the panelists for their Q&A session.
Yeah, if you don't mind, can we see a short demo or something? Is it ready? Like, can we see a demo?
The demo is not ready, but we can get it ready in 5 to 10 minutes. Okay, is it okay?
Yeah, it's fine. Chill, I guess let's take.
No issues over there. Hello.
Yeah, it's fine. It's fine.
Yeah, so Suyash here. Can you share the presentation once more? Actually, I had a couple of questions. So, can you share your presentation?
Yeah, Shivani, can you?
So, can we go? Can we go from the beginning? Yeah. Okay. So basically, what I'm understanding is you're developing a solution where you can pass on any article to your algorithm or maybe your program, and then it will kind of give you a summary. And if you want to ask some questions regarding that, you can get answers to that. This is the basic understanding of the problem set, right?
Yes, sir.
So, अरे server मत बोल भाई. भैया ही बोलते हैं, that's good.
Okay, bye.
So, yeah. So my first question is, first of all, you are translating any given language into English. So was that a prerequisite to the problem, or was it something that you came up with? We'll first translate it into English, and then maybe we'll do all the analysis on that.
We came up with that idea. Normally, it's easy to understand English for everyone. So we thought that that English would be a better means of communication, mode of communication. So we translated everything into English, and then we printed the summarization and heading in English.
Okay, got it.
It wasn't a prerequisite, so yeah.
Okay. Yeah, actually, I just wanted to point out one thing. So you were using a transformer model to understand the articles. So one short suggestion would be, maybe you could have used a multilingual model to understand the data set. And then maybe in the, you can say in the ending process, in the later stages, you could have used a translator. Because one of the problems with translators is you tend to lose information, right? So yeah, that was one short suggestion. Can we move on to the next slides? Okay, so what are languages were supported? The count of languages?
3 languages, Russian, Turkish, and English.
Got it, good. Can we just move it? Actually, why I'm asking you to just redo this, because I wasn't able to hear the first 5-7 minutes. There were some internet issues in my place. That's why.
Okay, not a problem.
Bhaiya, sorry, Bhaiya. Can I add a question here, if you don't mind?
Yeah. Go ahead. Yeah.
So I'm just curious. So you use pre-trained models, right, for the translation?
Yes, Bhaiya. Yeah, we use pre-trained models for fine-tuning.
Yeah, so the model already knows like translating the languages. So do you think fine-tuning would help the model like on a whole? Because in the end, it already knows how to translate. So your data set also should have repeated words, right?
It might help a bit, but I'm not that much. Fine-tuning on a certain data set that we are using, it will help gain some knowledge about the translation. It will improve its efficiency. Working on a certain project like this, like summarizing a news article.
Yeah. Okay. That's fine. I guess you should like you could have shown us the metric before the like fine tuning it, but it's fine. I guess. Yeah.
Just one question over here. What was your train split ratio that you were using for fine tuning?
It was 80 to 20, 80 to 20.
Got it. Got it. So your test accuracy. So you didn't do a train test validation. You only did a train validation. Is this understanding correct?
Yeah. Yes, Bhaiya. Yeah.
Okay. Got it. Got it. So your training accuracy stood at 99, and whereas your validation at 98. So I would say that this is a good. We can say that these are good numbers. Similarly for. Okay, so just one question over here. You are also training a translation model over here, right?
Yeah. Yeah, Bhaiya.
Okay. Then we can go ahead. Yeah.
Actually, I had one question around this. Can I go ahead, Suyash?
Arey, no problem.
So I was just a basic question. So your main task was getting the summaries of the news articles, right? So I'm just trying to understand why didn't you use just maybe a Google API to just convert like the translator, Google Translator to convert them? Instead, why did you go for machine learning? Like, was there anything behind that? Like, I'm just trying to understand like what was your thought behind it?
There was no specific thought behind that, Bhaiya. We just went with this. We could have used the Google API as well, but from the scratch we thought of using this.
Okay, cool.
I have a couple of questions. Could you let me go to the description slides? What was the problem statement? There's one thing particular I want to just clarify myself. Yeah. So in the presentation, you mentioned that it was end-to-end. I'm just trying to figure out the scope. End-to-end in from where? From the any particular, suppose there's a Turkish language, so you pick up from there. And do you give the output also in Turkish or it is there in English only? Do you translate it back?
It's there in English only, Bhaiya.
The output will be presented in English.
Okay, and the second question is how you are identifying whether it is in Turkish or Russian if I give you just a text?
We'll be using a language detector in that case, Bhaiya.
Could you like lead me to the slides which is mentioned there, detection part?
We didn't mention that in slides, but it's there in our code. We are using
Like,
language detector, we directly translate it.
Could you like, what are you, just an overview of that, what are you using to detect the language? Like Unicode is easier, but then suppose if there are two similar scripts, how you will differentiate between them? Like anyways, your main task, like one way to detect language is basically see what the encoding is. In Unicode, which set of character set is used, but what if the scripts are similar? But I think that question is not valid since it's just Russian and Turkish, so I guess it's differentiable. Okay, then good.
So actually, later in the slides, you were mentioning some more parameters, but there I noticed that you were only mentioning the training accuracies. So if you could go ahead, maybe in the task 3, it was
in the task 2 and 3, Bhaiya. In 2 and 3, we didn't use the validation accuracy. We only trained the model there.
Acha. Okay. Can you just tell me what is the task name over here? Task 2?
This is the summarization part, Bhaiya.
Summarization, okay.
So we summarized translated the article here.
Mm-hmm. And can you just tell me how are you minimizing the loss, or how are you actually defining the goal of summarization? mean, in a general sense, matlab, you are fine tuning it, right? So how are you going about it? Just talk me through it. Hello.
Yeah, Bhaiya. Basically, we took in the input article and then we fine-tuned our model. That's the Facebook BART base here. For this
Okay.
process on a certain data set, that's the CNN Daily Mail. We use this model because the BART is more it has a maximum rough score over the CNN Daily Mail when compared to T5 and Pegasus. So depending on this, we fine tune the model and then we used it on the input article.
Okay, ठीक है. Guys, you have any question over here?
Nothing from my side.
Okay, then we can go ahead. Actually, yeah, there were one factual question that I wanted to ask. So why did you take 512 as the number of tokens when you were fine-tuning BART model, I guess? That was the one?
Yes, Bhaiya, the BART one.
Yeah, so can you just walk me through your reasoning? Why were you using 512 tokens? Was there a specific reason? Had you done some kind of research? Yeah, what was your thought process?
There was no specific thought process where we just wanted to take a large number, so we took a 512. That's it. No specific thought process began.
Okay, cool. Can you just go through the next few slides?
Sorry to interrupt, but I think the time is up now. It's better to move on to the next team with your permission.
Okay. Just one last question. Just sorry, I know that it's over, but I'm quite curious on this topic. That's why. So can you tell me what is similarity score and how do you calculate it?
When we take a specific data set, we have the input article and a specific heading. So when we train our when we run our model on this input article, we get a heading and we compare it with this heading already there in the data set. So this gives us the similarity score, like the computer calculates.
Yeah, but what is the mathematics behind it? Can you tell me what is the mathematics? What is the core concept of how do you compare whether two sentences are similar or not similar?
Specifically, I don't know about that in detail.
Okay, I would suggest you to read about it. It's quite interesting. So what we do is basically we take a sentence and we convert it into vector. So all your transformer model is doing is it is converting your sentence into a vector. And then when we have two vectors, we basically take their cosine similarity, or you could say the angle between them, between the those two vectors in n-dimensional space. Okay, and that cosine score is your similarity score. So
okay, bye. Yeah, got it.
So I would suggest you to read up these kinds of things. Okay, it's understood that transform model बहुत detail में पढ़ना difficult हो जाता है, but you could look up कि what is similarity score or what is your training loss, मतलब वो function क्या है. So these can help you to build your understanding. So that is a suggestion from me. Okay, I guess Vardhan was.
Yeah, it's Vishnu.
Vishnu, yeah, Vishnu. Yeah. So we can move on to the next one.
Okay. Thank you, panelists, and thank you, Team ML3. Now we know that since the pandemic has hit us, a mask has become a part of our body. So we know how important a mask is. Now I'd like to call upon Team ML4 for the project on face mask detection. Team M4, you can start your presentation.
Okay, can you see my screen?
Yes.
Yes, there's no interruption, right? In between the presentation.
Nothing, it's fine, it's fine.
Okay, so
Good evening, everyone. So our model is face mask detection, and these are our group details.
I don't think it's going to the next slide. I'm sorry for that. Yes, it's good. Yes.
So what is face mask detection? Face mask detection refers to detect whether a person is wearing a mask or not. It is basically the reverse engineering of face detection. So the face mask detection basically comprises of two phases. One, the first phase is basically training and deployment, and the second phase is uh, implementation. So this is the basic workflow of face mask detection. In the phase number one, we first start with loading the face mask dataset, train face mask classifier with TensorFlow, serialize face mask classifier to the disk, and then we enter the phase two, in which we start with loading the face mask classifier from disk, detect faces in image, extract each face ROI, which is the return on investment, and then we apply face mask classifier to each face ROI to determine whether the person is wearing a mask or not. And finally, we print out the output. So the basic importance of face mask detection is to identify whether a person is wearing a mask or not. Normally, a human would be required to check, say, on an airport whether a person is wearing a mask or not. In this case, the risk of spreading a virus is high as the inspecting human himself have to deal with thousands of people every day. This will increase the probability of him getting affected. To stop this, we can use the idea of face mask detection, which will not require any inspecting human and hence will reduce the risk of spreading a virus.
So the first step is to create a data set to train the program. So to that we need to do annotations. Annotations are basically the particular information that on which the program trains. We have used the software label img. Details can be seen on the screen. Then basic information about annotations. Annotations are saved in a txt file, and it contains lines of numericals as seen in the following slide. It is seen that in the first numerical, it is stored the class of the object in form of 0 or 1, which is with or without mask. The second and the third numerical stores the x and y coordinate of the annotation, which is normalized, so is between 0 and 1. The last two of the numericals store the width and the height of the object in normalized form. The steps we need to do is download the piece of software, extract it, place all the images in a folder from which we need to train, prepare the classes. Then we need to open the software. It is the screenshots have been seen on the following slides. So when we open, it is seen like that with two panes on left and right side. To start annotating, we need to open an image and set the directory, and start annotating by clicking on the annotation button. We can see the preview here. So we need to first start annotating by using the button, and then drag our cursor across the object as diagonally as seen. We should repeat the step as all the objects are done, and select if they are with or without the masks. Repeat the steps for each and every image in the data set compress all the images along with their annotations and upload to the drive folder, which is required to train the program.
So now I'll be telling you about convolutional neural networks, which basically are specialized neural networks that take an image as an input and output a bunch of numbers, which are usually the probability values associated with the classes. So these are the models that we tried and tested. So basically, first we tried custom models using TensorFlow, Keras sequential models, which had batch normalization layers and max pooling layers and convolutional layers and so on. But the problem was that their accuracy was getting saturated at around 75%. So then we used MobileNet V2 model, which is a good model, but it cannot perform object localization. So finally, after trying SSD model, which is single shot detector, we didn't try that, but we looked at it. But finally, we fixated upon YOLO V3 model, which in a single pass can perform both object localization as well as detection. So YOLO V3 consists of two halves, 53 layers for feature extraction and 53 layers for bounding box predictions. So the detections occur mainly at three layers, known as the layer 82, 94, and 106. And at each of these layers, the image is divided into grid cells according to the stride value. And for each grid cell, we can predict three bounding boxes. And for each bounding box, we have 7 associated values: the x and y positions of the center of the object, the height and width of the bounding box, and the 2 values for the probability of the classes. So what goes in are the images and their txt annotations, and what comes out are the x and y predictions for the center of an object with respect to the top left corner of a grid cell and the corresponding width and height of the bounding box. So as you can see, the image is divided into grid cells. For each grid cell, we make a prediction, and then we ignore the redundant bounding boxes by a technique known as non-maximal suppression, which takes into consideration the intersection over union, which will be explained later. So these are the results of our model. So you can see it can detect multiple faces and even very small faces, as you can see. And this is a screenshot of our interactive portal that we created. And these are the model metrics we used a test set of 200 images and these are the predictions that we got. The accuracy was around 94% and the F1 score was 0.95 and the mean IOU is 79.44%. And the definition of IOU is given below. And the methods for calculating these metrics are given in the top right corner.
Now, this is all.
Okay, I think there's some problem.
Am I audible?
Yes, you are.
Now this is all about front end. We use Flask, CSS and HTML to create front end. Flask is a web framework which allows certain libraries and technologies so that it's very easy to make a web application. Now this is how a Flask and a web page and ML model communicates. What happens when you click the submit button on the web page? It transfers to Flask server, which sends the input to the ML pipeline, and from there we get predictions, and which again transfers back to the web page, and you see results in the feed. Now this is how we redirected HTML to Flask application using a submit using a form and app.root/. Now these are some challenges that we faced. We were getting some less accuracy with certain models like MobileNet and DarkNet, but finally we got we trained a model which was okay. Then there were certain hardware limitations that we are getting because the GPU power we needed to train our model was much higher. So we used Google Colab and we used all the email IDs to train our model. Now there were also some dataset problems, so we searched a lot of databases on Kaggle and other websites, and finally got one dataset. And there was a lot of time and there was we just annotated almost 400 to 500 images manually. So it was a very time-consuming process. Next slide. Next slide.
Okay. So now I'll give a live demonstration of our. Can you hear me? Am I audible?
Yes, yes.
you're audible.
Okay, so I'll give a live demonstration of our model now. This is the webcam detection. You see it, right? So this is me not wearing a mask, and
But
I'm
not
wearing a
I
headphone,
can't
so
see it.
you can't see it.
For me, it's showing that Google Drive page.
What can you?
Yeah, no,
Okay,
it's. I think if your network
fine.
is a
So
bit slow or my network, I don't know.
I'm able to see you. It's again that Google Drive.
now can you see my local drive?
No, it's actually stuck for me. Shavez for you guys.
I think there's some issues with his network, so it's a bit slow, and I can see his blurs.
Okay.
Yeah, I could see. Currently, I'm seeing your file explorer, and yeah, now I can see your video.
Oh, about new libraries.
Wait.
Right now, I'm
Okay.
seeing your file explorer, face mask
Now,
detection.
now can
Yeah.
you see the
Now,
webcam?
yes.
Yes, yes.
Yes, we can see.
So this is the webcam detector, and I'm wearing headphones, so just. And for the interactive portal, so can you see the interactive portal? So basically, this is hosted on a local server, and then you click on this. Can you see it?
Yeah, we can see the page.
Yes. So can you see the webcam now?
Yes.
Yes. So this is basically, we tried to make this live, but Heroku had a 500 MB limit, and our weight file was too large, so we couldn't make it live. But it's hosted on a local server currently, so we did that. Thank you. Okay, so we're done.
Yeah, so firstly, I just had a small correction. So ROI is not is region of interest.
Yes, it's region of interest.
So, and how
maybe
heavy is the model? Is the model heavy? Like it feels like it actually has bulked up the whole. It was so heavy for even WebEx to get stuck and all from your laptop. So is it heavy, like the model? Does it
No,
consume
my no, my internet is bad. I use a hotspot actually.
Okay,
So.
okay.
Then
yeah, my
I had
question
two
was,
questions.
yeah, no, go ahead.
Okay, like just two small questions. So firstly, you told your initial models were saturating at 75%. So like, did you look into it? Like, why was that happening? Was there any reason why YOLO
Yes.
then did better? Yeah, go ahead.
Yes. So what actually was happening was that the model was not big enough to categorize all the weights, and what was happening was it was oscillating around the minima, and it was not reaching the minima. So suppose the minimum loss was 0.5, then it was reaching let's say 0.8, and then it was going back to 0.9. Again, it was going back to 0.8. So maybe that was because the model was not sophisticated enough to predict all the large data set.
Okay.
It was
Also,
working on
yeah,
single
go ahead.
images. It was working on single faces, but when there were multiple small faces, it was failing.
Okay, got it. Also, the data set, like, why did you generate, like, why did you annotate the data set? Was it not available? I think there might be data sets, right, for the face mask detection task, or was this also part of your problem statement to, like, do the data generation as well?
Actually, we couldn't find any TXT annotations. All were based on JSON or XML files. So basically, we had to generate the text files.
Okay, got it. Okay, it was your requirement to have an TXT, I guess.
Yes. Yes.
All right. Also, one suggestion, if you still want to maybe run it online, maybe you can try pruning your model. That will maybe reduce its size, and maybe if it's less than
Okay.
500 MB, you can host it on Heroku. Okay, that's it from my
Okay.
side. Yeah, great work by the way.
Were those all the questions?
So I have a small suggestion actually. So in one of the slides where you were mentioning all the metrics, right? So
Yes.
what you could have done is you could have drawn the confusion matrix. That would have been
Yes.
much more impactful
Yes.
to just directly understand, okay, what are we looking at, rather than
Okay.
mentioning true positive, true negatives. So that is a small thing. We learn like that only. So that could have been done. And another thing on presentation itself, I want to comment is I found that there was too much information in slides, like you were explaining in too depth. So when you create documentation, that's good. You know, as much you should go in detail as much as possible. But when you're creating a PPT, just keep it to the point, keep it short. Okay.
Okay.
So these are the things that maybe in the future you should look at, and it will really, really help you. So
Okay,
these
sure.
were two suggestions.
I have a couple of questions. You mentioned that you tried looking for quite a number of data sets. Could you give an instance which one and why you chose? Why you didn't
Okay.
choose some of them?
Okay, initially, what the first thing we wanted to establish was single phase detection, that is not localization, just a single phase. So for that, there were many data sets on Kaggle. You can just search for them and you can find them. Single image data set. But for multiple phase detection and localization and detection, we had to actually generate the data set from Google. So, and there was one dataset on Kaggle called medical face mask, which had some images, but many of them we had to generate from Google using download all images. And then we deleted.
Okay, there were not many data sets present where there are multiple face masks on there, right?
Yes, like people with multiple faces, and yes, basically.
Okay, that is understandable. And maybe I missed, but could you guide me if what are the metrics that you gained and any improvement on?
Okay. Should I share the screen or should I just tell? Okay.
Yeah, sure. Yeah, you can let me know as well.
Okay, so basically for we tested on 200 images and we got 294 detections, and true positives were 190, true negatives were 86, false positives 10, and false negatives 8. Accuracy was 0.9388, and F1 score was 0.9530, and mean IOU was 79.44%.
That's good. And since you used something, maybe you mentioned about the architecture, so I guess comparison is not a big issue with that. Yeah, good.
Were those all the questions?
Also, just a small thing. So, when you told that the dataset has JSON and TXT, where you wanted TXT,
Yes.
so what did you exactly mean? So, does the JSON already have whatever data you want, but in a different structure?
Yes, there were actually, I found some converters basically that convert the XML to YOLO annotations. but just to prevent any errors, because the annotations we just had to spend we were 4 people, so we divided the images 500 per person. So I thought that would be error free, because if in the conversion process there was a small error, then it would lead to a much bigger problem.
Yeah, just a suggestion. I think we can just code something like that in Python and just like
Yes,
do that.
I did do. Yeah, there was. I did find that converting the XML annotations to TXT, but the images, I guess, were not the images we wanted, and the annotations that were present, they were not, I guess, compatible.
Okay.
Like pardon me, but I don't really understand what was the issue. Like if you have a JSON file and you want to make it into a TXT format of your choice with the labels of the annotations. What
No, but
was the main issue over there?
the images, right? Because the images were not the ones that we wanted. They were mostly single face images.
Yeah, okay. But what was the issue on JSON that was being asked, I think? Image part I can understand.
Okay, Jason, basically, I was a bit we were a bit apprehensive that maybe if in the conversion process, if there's any, a very small error such as a new line error, or a big error such as the images, the format of the images, maybe. I don't know, but I just didn't want an error to come across because of annotation. We just had to spend a day or two maybe on this, so I didn't think it would be much.
Yeah,
We
just
have been
just
aware. Sorry.
yeah,
Just
you
one
go ahead. You
final
complete your point.
conclude
Complete your
it up.
point.
Yeah. Like as a panelist, we have been informed about the constraints. So I don't think, on a personal note, I will be like picking you on this. But I think when you are making an ML model, you are making it for a scale, and instead of hesitating, you should do and test if it is working or not. Try to test things are working well or not.
Okay.
In any ways, try to automate as many things as you can. But yes, okay, it's fine because we know the time constraints. They were on your side.
Yeah, actually, I was also trying to mention the same point itself only. Just try to open the file and, just open that JSON file and see how the data is presented. So it's kind of a dictionary structure itself.
Yes.
So मतलब थोड़ा सस्ता लॉजिक लिख लिया होता या फिर स्मार्ट लॉजिक जो बोलते हैं ना, it could have worked out, but yeah, it's no issues. That's how we learn. मतलब first time I also did lot of stuff manually, जो later पता चला अच्छा 2 लाइन से automate हो जाता. So these are the things that you learn later, but आप लोगों ने effort डाला, that's pretty good.
So thank you, panelists, and thank you, Team ML4. Now moving on, I would like to call upon Team ML8 for their project on image capturing and video summarizer. You can go ahead, Team ML8.
Yeah, can I start my presentation?
Yes.
Yeah, can you see my screen?
Yes, you can see your screen.
Okay. Yeah, hello all. This is Team ML8, and our project is image captioning and video summarization. And the problem statement basically is we had to develop a model which can generate the captions, and we further extended it for video summarization as well. I mean, it has to generate some paragraph sort of thing for what are the things happening in video summarization, and that was our problem statement. And here you can basically see our approach. Uh, Here we have downloaded the dataset, and the dataset we used was MS Coco dataset, which has somewhere around 80K images, and then we pre-processed those images and captions, and later we prepared the training data in a TensorFlow dataset format, and we've done that because we can load the data efficiently. We can load the data in form of batches, and this will be helpful in saving our RAM memory. And later this formatted data will be transferred through CNN encoder and simultaneously attention module, and further it will be passed through GRU decoder, and finally this decoder generates the words, and this sentence generator finally is used to generate a sentence. Yeah, I mentioned all these things which are presented in this slide. Yeah, and for data extraction we've used ResNet 50 model, which in which we removed the at last fully connected layer, so that we'll be converting the images data into a NumPy format, into numerical format. And one more limitation we took was the ca- to, we took the vocabulary size limit up to just 5,000 words, keeping the computational limitations in our mind. And later we also created word to index and index to word mappings on all I mean on and we have done the post padding for all the sequences to make all of them having same length. Next, here you can see the ResNet model which we use for feature extraction. I mean, for converting the data into that format, like a NumPy format. And next, uh, yeah, here I've explained the same thing. Like we are converting the images data format into NumPy file format. Next, Aditya, can you continue from here?
Yeah. So basically, in the model we use attention mechanism, in which the decoder uses the certain parts of the image which we extracted using the ResNet 50, so that it can give more localized word output words. Next. So this is the pipeline of our model, in which the final outputted CNN encoder tensor is passed through the decoder so that the GRU is getting the inputs from the attention combined with the encoded image and passed through the GRU, so that we can get more outputted, more precise outputs. So in this model, we used teacher forcing. So we faced a lot of computational problems. So we tried to reduce these by decreasing the model size and parameters, so that we can run it in our local system or Google Colab. So basically, the combined encoded files and are passed with attention and into the decoder. So then the outputted word, the outputted word from the GRU is directly calculated loss is passed, so the error does not accumulate so on, because if the error accumulates so much, we cannot train it faster. By using teacher forcing, the model can converge faster by calculating the error of each outputted word there itself and move on. So we trained the model with 50,000 images. We split it into 95 and 5 for training and validation. So in this there is no validation accuracy or something like that, because there is no specific metric for accuracy calculation. We used cosine similarity to check how similar is the outputted caption to the actual caption. So we used 256 word vocabulary embedding size and two GRU units and fully connected layers. So next, we use GRUs instead of LSTMs. So the GRUs work better, has less training time and less parameters, which helps in training the model faster. The model took a lot of time to train, so there was a lot of difficulty there. We weren't able to check many possible options. Can you continue?
Yeah, I will continue. Hello?
Yeah, we are able to hear you.
In video summarization, basically, first we'll be taking a sample video, and then we'll be converting the video into set of frames using OpenCV library. And from those specific set of frames, we are going to capture the frames at specific time interval. And we decided that as a 1 frame per 2 seconds. I mean, we are going to capture 1 frame out of every 2 seconds from the video. And later and we are going to store the paths of all these specific frames in a list, and then using the above said image captioning model, we are going to make predictions on these frames. And the set of captions that are going to be generated will also be again stored back in another specific list. And later we'll be performing we'll be converting all these predicted captions into a single paragraph, and then we are going to perform text summarization using T5 based transformer model. And here the process we are going to perform is abstractive summarization. And one more thing I would mention is, here we performed beam search instead of greedy search. Here beam search looks for next possible 3 or 4 words rather than checking for next probable 1 word. And inference, yeah, here we mentioned the observations we made. Yeah, for in training we've used a teacher forcing method for faster convergence. But here actually for some random image outside, we don't have some ground truth captions sort of thing like that. So here we are going to make a small change compared to training. That is like here we are going to append the predicted word itself into the input sequence, and we'll feed that back to the decoder for the next time step. And here for image captioning model, we preferred greedy search rather than beam search. And basically greedy search checks for the next highly probable word, and one more thing was we observed the cosine similarity of 50 random images. It was from test data, was somewhere around 0.82. And yeah, 0.82. And next thing we observed was our model was performing better when there are lesser subjects in the image. Lesser subject in the sense like maybe lesser human beings or animals or something, and maybe lesser sort of actions were performing in the image. In such cases, our image captioning model performed better. And yeah, here you can see some of our predictions for that image. This was taken from test set, and for that image you can see the original caption as well as the generated caption too. And we also calculated the cosine similarity between these two, and it was around 0.78. And here this was some random image from internet, and this was the caption generated for that image. And yeah, future enhancements due to some computational limitations and time limitations while we are running in the collab, we limited ourselves to some extent. And for further enhancements we can add for model something like this. Yeah, training without teacher forcing. Yeah, this will this is one thing. And we can change the hyperparameters like vocab size, embedding dimensions, and we can also increase number of epochs as well. uh, and one more thing was increasing the model complexity, adding further maybe one or two GRU layers possible. uh, and one more thing was using LSTMs instead of GRUs. Here we preferred using GRUs because GRU requires lesser parameters, and it will be finished in lesser time compared to LSTMs. And one more thing in video summarization part was actually rather than using T5 based transformer, using T5 large. T5 large is somewhat a larger version of T5 base, and this T5 large will produce good and better results compared to T5 base. And using this T5 large can also be done in summarization, so that we can obtain further better results as well. And next thing is, yeah, these were our team members. And yeah, thank you.
I'd like to invite the panelists for the Q&A session.
I think it's just a comment, not a question. You use cosine similarity. I think if you use some more metrics, you may get a better result, because cosine similarity is still very basic. It's just like either use this or use a bag of words to see if similar. But I think what results you have mentioned, they may be a bit more better because cosine similarity is a very basic metric. But yes, overall.
We were asked by our mentors to use cosine similarity as our metric. That's why we have to stick with cosine similarity.
Yeah, that's all right. Like, I'm saying that your project
okay.
is better than what is being shown over here.
Okay.
Also, Aditya, I had a question. So you showed like maybe similarity one time for 50 random samples and then for few images. Then do you have a compilation like of maybe the whole data set that you are having a score for that?
No, I mean it took a lot of time just to run for 50, so I didn't make much sense.
So like you're basing all of this on those 50 random samples that you selected. Like I guess it was around 0.82 that
I
you
mean,
had.
I tested 1 hour, like for the first 1,000 images in some random in the dataset, the cosine similarity was above 0.9. So that's the one thing I did.
Okay, so for 1,000, you tested around for 1,000, and it was
it was around 56%. Like 56% of the images were above 0.9 cosine similarity. So.
So, hi. So, nice that you picked this thing. So, I just had a query. Like,
oh wait, just a second,
yeah,
Abhiram.
okay.
I just got to know I was
Yeah, I thought
muted.
your question was done. So, shall I continue?
No. I said something, but it was on mute. So, what I was saying was, if you have some metric like that, Aditya, like 1,000, you said, right? You had something for 1,000 images.
Yeah.
Maybe mention that in slides, like next time, anytime you do
I
such
mean,
thing.
I'm sorry. I mean, that was done today early in the morning, so I was not able to update in the.
Yeah. I'm just suggesting, like,
Okay,
yeah,
thanks.
have it in presentation like that. Finally shows that what you did was successful.
Okay.
Yeah, go ahead, Abhiram.
Yeah, so that's nice that you picked this project. Like, it is a bit complex given the attention model and everything. So, yeah, I just had just a little suggestion, I guess. So, I've seen like this actually, I took this workshop in Experiment before. So, yeah, this thing like the LSTM and GRUs, when you use them, it actually takes a lot of time, right? So,
Yeah.
I was just giving you a suggestion. If you would explore for other options, you could have readjusted a transformer to do the same here.
I mean, we tried to implement a transformer, but we were facing a lot of errors in coding it. So we had to stick with GRU. So we were not able to spend a lot of time on it. So.
Okay, that's good.
We were actually thinking on, in the starting, we actually thought on doing a transformer, but we were not able to do. So,
Yeah, that's good.
One suggestion, I think your slides had too much text when you were reporting data. Try to use tables if it is needed.
okay, okay.
Also, is there a video summarization sample or something? Like that was also a part of your task. So if you can see that sample, it will be good.
Yeah, yeah. Actually, I can present you video and individually, and I can show you the text which I got in
Yeah,
collab.
yeah, yeah. Just
Yeah,
that.
yeah. Just a minute. Just a minute. I'll do that.
Yeah.
Bhaiya, can you see a video on my screen?
I can just see the presentation at thank you page.
Oh, okay, okay. Just a minute, bhaiya. I think I had to present. Now have you? Yeah. Now can you see that video?
Nothing yet.
Still the thank you slide.
Okay, okay. Just. Yeah, I think you can see it now.
Yes, yes.
This was the video.
How's it going, baby?
It's a 3 minutes video approx.
Not even town. I'm here. Yeah, but you're my mom. You live on the premises. At least Dr. Sturgis should be here any minute. Shelly, I'm afraid Dr. Sturgis isn't coming this morning. Why not? He isn't feeling well. Oh dear.
I guess. I think I know the scene. I actually know the scene. What happens like they show all the
Okay,
other
okay.
characters. Yeah, just show a summary. I guess.
Yeah, I'll show the summarization. Just a minute.
Yeah.
But yeah, I think you can see it now.
Yes.
Last cell output.
All right. All right. Good.
Okay.
So we have somewhat to work on our video summarization part.
So just wanted to know one thing. When you experimented with the transformers, which library were you specifically using?
I mean, for video summarization transformer.
For video or for image, anyone? Just wanted to know, what kind of libraries were you using?
So the image captioning was done from scratch using TensorFlow framework. Like they didn't use any.
That is fine. That is fine.
Okay.
So,
Yeah, for transformers,
you
we used one was sentence transformers.
Yeah, so just wanted to know which language. Okay, sentence transformer sentence transformer library itself. That is
And
the one you were using.
and another one was its name itself was transformers.
अच्छा, okay, ठीक है. Hugging Face
it
से
was
आते हैं ये
from
दोनों.
Hugging Face.
Hugging Face से आते हैं.
Yeah, actually, we can use
Okay.
Hugging Face that as well, but
Just Hugging Face itself.
Transformers implementation, Transformers library is from Hugging Face. I'm surprised because their मतलब जो their way of coding is quite simple and मतलब एक linear fashion में चलता है, तो I don't think you should face much errors. But anyways, that's part of it. Also, I wanted to understand one more thing. Why were you limiting the vocab? It's understandable you would limit the vector dimensions to limit the training size, training time and stuff. But why were you limiting vocab? Because the more vocab, the better the model can actually give the final output, right?
So we were limiting the vocab because if there are a lot of words, the model is getting mixed up with different similar words and giving different outputs like random images. So that's why we have to.
So, acha, okay. So because you were training the model from scratch, it can pose a challenge to you.
Yeah.
So if you are using a trained model and fine tuning it, then you won't be facing this limit. Cool. I mean, it's a good attempt.
Yeah. Thank you, panelists, and thank you, Team ML8, for the presentation. Now, I would like to call upon Team ML10 for their project on face recognitions. You can go ahead, Team ML10.
Hello? Hello?
Yes, you're audible.
Okay, thank you. So, is my screen visible?
Yes, it is, yes.
Hello guys, good evening everyone. We are going to present the face recognition project built under the IITISoC, and our team code is ML10. So here are our team members, Amit Kumar Makkar, Priyan Jaseja, and myself, Bhavya Contractor, and our mentors are Miten Shah, Anjali Singh, and Bharat Gupta. So here goes the problem statement. So problem statement states that we have to build a model which recognizes the faces in an image, and also to develop a web interface for the same. And also we had to add a functionality with a feature by which the admins can upload the image and the system must be able to recognize it. So these were the three main tasks which we had to do. Now, basically, firstly, what is face recognition? So face recognition is a way of identifying and confirming the individual's identity using their faces, and it is one of the newest and trending technologies used in various fields, and it is quite useful. And also, it uses computer vision to recognize the faces. So this was about face recognition. Now uses, if we talk about uses, then the first and the main use of it and the most widespread use of it is to unlock phones. Like each and every phone nowadays has this feature to unlock it using the face recognition. The second, the one most important is to track the school attendance. Like it automatically detects the faces of the students and marks the attendance accordingly. And the third one is to have a control access to sensitive areas. And there are many uses like this. So these are the uses. Now the approach, what approach we followed. So firstly, we started with exploring the face recognition library of Python. So we started, it is quite interesting library. And then after learning about its various features and functions, we started on to making a basic face recognition model. Then we moved on to deploying our model on the web interface. So for that, we explored about Flask framework, which is quite useful for this purpose. And then we moved on to develop the front end using Bootstrap. And finally, we combined all of these things and completed our project, laminating the web interface along with the model. So this was the approach which we followed. Now here's the task one, which says the building the face recognition model. So as you can see, the step one is to capture. So basically, here in this model, we are using webcam, and from the webcam, we are giving frame by frame input to the model. So that's how input is given. And the step two is to extraction. So by extraction, we mean to find the features, some important features from the image. So basically, the model, so the input image which we have given to the model. So the model finds the encodings of the image. So this is step two. And the third one is to comparison. So once we have the encodings of the image, then these encodings are compared with the encodings of the images in the database. And we can even find the distances of the input image from the images in the database. And for the fourth step is matching. And finally, the image name with the least distance from the input image is printed. So that's how the basic our basic face recognition model works. So this was task one. And that basic model focuses on Python, and the various Python libraries they have used are face recognition 1.3.0, OpenCV Python, and Flask. So face recognition and OpenCV are for building the model, and Flask is for making a web interface for the same. Yeah, so OpenCV Python is an open source library used for image processing and identifying faces in objects in the images and videos. And the second important library which we used was face recognition, which has various functions by which we can easily load the image and find its encodings, and also the distances and compare it with the images in the database. So these were the two important libraries which we used. And the third one is to here we are using one-shot learning, which aims to learn information about the objects with only few training examples or images, irrespective of other algorithms which require hundreds and thousands of images or very long data sets. So one-shot learning we have used. From now, my friend Priyansh will continue. Thank you.
Hello, am I audible? Hello.
Yes, you are. Yes.
So from here, I will be continuing. So this is the task two of our project to develop the web interface for a model. So we decided to divide it into a two subtasks. That is to subtask one, that is to develop the front end of our web application, and the subtask two, which is to develop the back end of our web application. So the subtask one, which was to develop the front end, we basically used the HTML, CSS, and the Bootstrap to develop the front end, and we have made a lot of pages, total of 5 pages for our web application. Next. And for the backend part, we have basically used the Flask framework, which is built in Python and is used to deploy the models on localhost or online. Next. So here in the diagram, you can see there is a navigation of the web pages from our web application. So the first two pages are the home page and the recognition page, and then it's the login, dashboard, and uploader page. Next. So this is the home page or the first page where you will land on a web application. On the top, you can see there is a navigation bar on which the first element is the get recognized, which will refresh or you redirect to the home page, which is where we are. And the second is the admin control, which I will be talking a bit later. And the third is the GitHub project link, in which there is a project link of our project. So, and there is some steps, and at the end there is a start button which will start a model. Next. So this is the recognition page, and this is the screenshot of our third teammate Ahmed while running the model. And there is a window which takes the input from the webcam and shows the bounding box around the face and with a name beneath it. Okay. And this at the end there is an end model which will redirect you to the home page. And here you will be landing when you will be clicking on the admin page on the navigation bar. This is basically a login page for the admins which if you inputted the correct credentials, you will be you will be redirected to a new page, that is dashboard page. Next. So this is the dashboard page where you will be coming from the login page. And so it basically takes the three inputs, that is the first name and the last name of the person from which is in the image, and a file can image file which can be in any format. And it has the two buttons, that is upload and the logout. Logout is for logging out, and upload is for uploading the image, and which will you be shown after which you will be shown an message uploaded successfully. Next. So this slide contains some unique features of our model. That is, the model which we use is based on the face recognition library of Python, which has an accuracy of 99.38%. And our model is based on the one-shot learning, and it recognizes the faces in the live video and identifies the name of the person if it is in our database. And the third is it can detect the multiple faces that can be recognized at the same time. And fifth is the admins can add images to the database. Our journey with the IITISoC. So what we learned from the IITISoC, that is, IITISoC gives a platform to our platform where we can learn the machine learning and the web development. We got a kickstart to the machine learning by this, and we got to know about various libraries in the Python, and we got to learn the time management and the teamwork. Next. So thank you. And now my third teammate will be presenting the live demo of our model. Okay, Amit, you can start sharing.
Yes. Is the screen visible?
Yes, yes.
Okay. This is the demo of our model. This is the home page. Here is the get recognized admin control, and here are some steps. Now I am going to start the model, and currently in the database my image is not present, so it will be showing unknown, as you can see here. Now I am going to end. Okay, now I am going to the admin controls. I am putting the username and the password. Now I am uploading the image with the name which I want to be appear. Then I am adding my image. The image is uploaded successfully. Now I am going to the web. Now you can see my name Amit Makkad is printed because I have added my image in the database. Okay, thank you. This is our model. Right. Okay, that's it from the side.
Yeah. So I just have a small query, I suggestion or something. So yeah, so the model, can you just give me a small an explanation on the endpoints you used for Flask? What's the backend transfer going on from front end and backend? Okay. Okay, yeah, wait. So you are not using any separate framework for the front end. Okay. It's not a REST
No,
API. It's just a web server. The Flask is a web server.
Yes.
Yeah. And also
Like,
I was actually going. Yeah.
Like, I didn't understand the question. What you are saying?
Usually the front end, you can have a REST API, you can have a separate endpoint, which when you just query, send an image file, you just process it and send you the coordinates to of the image. So, and you can have a front end which is separate on another server, which can call for the backend. So I thought that was your architecture. I just mistook it.
No, the entire is made on the Flask, and I didn't have used that.
Yeah, HTML templates, right? Yeah.
Yes.
And just a small, I thought of asking, giving you a suggestion, but given your admin and other functionality which you added, I think that's not possible. I thought maybe you could have used it, the JS part of the browser to just do it on the system. So rather than giving it to the server. But yeah, the model will be in the people's hands. So, yeah. Cool, cool. Done. That's
So everything is in Flask, right? Or you are
Yes.
using a separate database API?
No.
Okay, okay.
Actually,
So
I have a suggestion for maybe all the teams in general. So if you are exploring libraries like Flask, I would suggest using Fast API. So it has its advantages over Flask, and it is much faster to prototype on that. So a point that maybe all of you can explore in the future. Yeah,
Yes,
Shavez.
sure, we will do.
Shavez, you were saying something.
no, I was done. Yeah, my question was that.
Okay, I have a question, not a question actually. I was just curious. So you add your image and it recognizes you. Have you tried like how maybe currently you are sitting in the same environment, right? With same lighting conditions and stuff, but is the model not underperforming, or is it performing the same if you also have maybe a completely different environment in which you're taking photo, or is it performing great in that as well? So like have you like tested it out like in
Like
that?
if the frame is moving or it's like it's if it's constantly changing, then our model is underperforming. But if it's constant, like then it will not suffer a lot.
By constant, what is constant here? I didn't get you, sorry.
Means the frame is constant, like the back frame. If I am like moving my camera like that, then it will underperform.
Okay, no, I was talking about so currently you give the model your image and it then accounts you also in the database and tells that you are the person. So if you have an image from maybe uh, like some other environment, is it underperforming, like maybe some different lighting conditions and stuff like that?
No, it will perform. Matlab, means it's not much drastic change, but it will little bit, but it will mark me as Amit Kumar. Means it not
Okay,
much.
okay, got it. All right.
I have an extension to the question that Nemath asked. I think that was a good question. How is your data flow going? If on the front end side, is there any validation or like just guide me on how your data flow is there once the user clicks the photo. So what I could see is that you're sending the whole PNG file to the model directly, right? Or is there anything
Okay.
in between?
Okay, should I share my code with you?
Yes, yes, yes. I'm trying to figure out one specific thing that's why I'm asking.
Yeah, just by the time he's sharing it, there was another question. So you were using distances, right, within the algorithms?
Yes.
So what kind of distances were you using? And so that is one. And second question is, in the very beginning, there was one point mentioned that you had explored various libraries. So just curious to know what all libraries had you guys explored, and what all models you had explored for implementing this.
Okay.
About the distance, I would like to answer. Like the distance of the encodings of the images from the database and the input image. So distance refers to the difference of the encodings.
Yeah, so, but
Like
how are you calculating those differences? Is it
like here,
directly Euler distance or?
like here you can see
I
from
think
the
it's
function face
Euclidean. Yes.
recognition dot face encodings, we are this is the current frame and this is the frame. This is the frame in the webcam and this is the previous frame, like in the data which in database, and we try to compare all of this, and from there we find the distance by this form by this function.
Okay,
Yeah.
so one question is that, yeah, sorry, I'm interrupting. Yeah, go on.
No. Go ahead.
Actually, the thing was that I'm trying to understand is that the encodings is the final thing that is going into the model, right?
Yes.
So is the encoding done on the front end side or on the back end side?
It's on the backend side.
Okay, so who is your target application? I may ask, like, is it an authenticate? Who will be your target user? An authentication person or some real-time application? What
It's
are
a
you?
real-time application. That's why when I added my image, it's currently able to show my image. I did not use to like restart the model.
Okay, so yeah, okay. Like I'm not
I'm
sure.
rephrasing
Having
Chavez. I'm rephrasing your question, Chavez, a bit over here. So, like,
yeah.
if you were to give this model to someone with authority in the campus, who would that guy be?
Yes.
मतलब इसे टीचर को दे सकते हैं, प्रोफेसर को, तो अटेंडेंस सिस्टम में वो लगा सकता है. Is
Yes,
it
we initially
security
thought of
force पे?
making a attendance system, but due to some time constraint, we are not able to add it.
That is fine. That is fine. We are not telling you to
Yes,
give
we
it right
can
now,
give
but
it anyone.
what is your
Yes.
target audience over here, and how do you plan to use it? I mean, एक security barricade पे भी we can put it there, right? Where anyone enters, exit, he doesn't need to write his name or punch his fingerprint. Directly उसके face से हो जाएगा. That could be a
Yes.
potential application. So, what were your initial thoughts कि कहाँ पे use किया जा सकता है?
Actually, when we started the model, we think of making a school track attendance system. But due to some online classes, it's not. We are also not able to like implement it. Means
That's
we
fine.
can.
That's fine.
That's why we
Yes,
just
sir.
stop there. Also because of time constraint. Also in future, if we
Yeah.
get some more time and when we are in offline, we will try to make it a school attendance system, which we initially thought.
Yes, so I think we had initially had a plan. We had a plan like when the person joins or the student joins the class, then the faces is automatically detected and attendance is marked. So that's what we initially thought of making. Yeah, so in the online classes, definitely, yes.
Okay. Yeah.
Like it
So,
further works.
and going back to my previous question, okay, I just wanted to get a clarification on what kind of algorithm you were using to calculate the distance. So, I don't see a very specific name that's mentioned. So, okay then.
Actually, distance is calculated by the function with the library, face recognition library Python provides us to find the distance. It's basically based on that CNN
So yeah,
networks.
you are using a face distance function, right? So have you
Yes.
explored its documentation key? How does it actually calculate the distance? Because had you done that, you could have matlab, very clearly understand. Okay, these are the things that are actually important for the model. Yeah, these are the things. These are how this is how things work. So this was something that I was expecting. But yeah, nonetheless.
No, also like we have studied that the CNN networks, which when an image is there, it tries means it converts into a NumPy array of pixels in RBG form, and after that it's converted into an array and then it's stored in encoding. And from that encodings, we are calculating the distance between the current web frame and the previously calculated image, and which image has the least distance from the current image, that image name is printed, otherwise unknown is printed. If the distance is more than 1.5, unknown is printed.
So I just pulled out the documentation. So if you see, it is directly mentioning over there that it use a Euclidean distance for phase comparison. So I just wanted that particular word ki haan bhaiya, we are using Euclidean distance. That was the answer.
Yes, yes.
So I was expecting something like that in the slide itself, but yeah, okay. And you mentioned that you explored various libraries. So apart from face recognition library, which other library had you explored?
OpenCV.
So OpenCV, as far as I know, its application, it's mostly for image handling and manipulating
Yes.
images. Specifically for model building, keeping model building in mind, or for models, what kind of libraries did you explore?
One second. I will.
So you implemented one-shot learning as well, right? So
Yes.
So one-shot is coming from which library? It should be from face recognition.
Yes, it's coming from face recognition. And for some path connecting, we import OS. And from Flask, we import a render template, response, request, session, and redirect. And this library for secure file. Yes.
That is fine. That's all fine. Just wanted to, you mentioned in the very first slide that you had explored various other libraries. So just wanted to you guys to name a few. कि मतलब और कौन से किए थे?
Okay. Okay. The previous had asked about the code flow.
Yeah, no, I got cleared. I got a sense. What I was thinking that you use Flask, which makes things very easy to implement and pretty fast to prototype as well. But since if it would be deployed for authentication purposes, say for example in a public place, I was expecting some security aspects as well. How are you storing your images in the database? Are they encrypted or just like that?
No. In the this folder, 2 images are there, and we are storing in that images. And for our ML model, we are encoding all the images which are present there. And just we get it into the machine learning model, and we started like encoding them.
Okay.
In the model itself, it is getting encoded.
Okay.
Chavez, I think if we really talk about security and stuff, then it will be a full-blown project, I guess.
Yeah, exactly. That's why I was just
Yeah.
prompting on that. I am not very
Yeah.
particular on
I
that,
don't
but I still
really think
expected.
it would really come under this scope. मतलब एक
But
full-blown project हो जाएगा,
I
and
still
they would require
expected
far
the
more
data
resources.
processing to be. I still expected the data processing to be a bit more modular because of the target point. Because it is using a Flask
Right.
and image inference. So
Yeah,
what
sorry to interrupt, but it's quite long now. Can we move on to the next team with your permission?
Yeah.
Yeah, fine. So the next team presenting will be Team ML11 on their project on ads click-through rate. So ML11, you can start your presentation.
Thanks, Vishnu. I will be just starting in a minute.
Sorry to interrupt. Can you just give me 30 seconds? Just 30 seconds, and then we can start.
Yes, sure.
Yeah, we can go ahead. Yeah.
I hope my slides are visible.
Yes.
Okay. So hello everyone. Today I will be presenting our model on ads click-through rate. And let me first give you a brief introduction of what is click-through rate and CTR and its significance. So CTR stands for click-through rate and is the number of clicks that your ad receives divided by the number of times your ad was shown. The number of times your ad was shown is also known as impressions, and is a very important metric for evaluation for our keywords and ad performance, and is widely used for sponsored searches and real-time bidding. Uh, so the task for us was that given a user and the page he is visiting, we had to find the most benchmark the most accurate ML algorithm for CTR estimation. The data set that we used was from Avazu, from Kaggle on the Avazu CTR prediction competition, and had consisted of 10 days of click-through data ordered chronologically. So our approach was to first collect the data, then split the data through test, split and test, train and split, and then we had to check for the some missing values, and then we had to check encode our categorical features to use in the model, and scaling the of numerical features for faster processing. Then we had to do some feature engineering for getting good results, and then we had to then there was model training and testing and hyperparameter tuning, and then finally we had evaluated our model's performance.
So as I said earlier, the data was from Kaggle data, but it was very large. We had hardware constraints of format, like the CSV file was about 6 GBs containing about 40 million entries, which could not be used at once. So we had selected initially for our all initial sets, we selected 1 million and random entries, but in the end we for the final model we could use 3 million entries with our hardware. And the
Sorry to interrupt you, but one of our judges have disconnected. So I request you to kindly wait for a minute or so.
Yes, I'm here. Continue.
Okay, shall I continue?
You may continue. Yes.
Yeah. So the benefit of selecting random entries was that if we have selected suppose entries from suppose n rows from top or in the end, so we might have missed some features, some information which might be left in between. So selecting random entries ensured that we do not miss any values, some information. Then checking for the null values or not a number values. Unfortunately, there were no null values in the data. Next, here is the look at the features and the data types. Giving you a visualization of.
Sorry to interrupt again. Just can you go back to the previous slide?
Yeah.
Just going through the various features. Can you just walk through what are these features?
So ID is the ID of the ad of the ad shown, and R is the R of the day, in the 24-hour format, and C1 is a anonymized categorical features, like it is kept anonymous, means having some sensitive information like C1 and C14 to C21. And banner position are the banner positions of the ad which were shown like positions on the web page. And site ID, site domain, and site category are the features of the site. And similarly, app ID, app domain, and app category are the features of the category. And device ID, device IP, and device model, device connection type, these are features for the user and the device is using. And then our label was to find the clicks.
Got it. Thanks.
Okay. So moving on to giving a visualization of the data. So the first graph on the left, we have a graph for the count of the clicks. The red one is non-clicks, and the blue indigo one is the clicks which were actually clicked. So from here we could get about the CTR. We could estimate that the CTR was around 17%. Next, the graph on the right shows the click trends of a hour of the day. So in this we can get information that the maximum clicks were from 1000 hours and 1500 hours. Next, we have the click trends of the day of the week, and in this also we can get information about click trends from that there were maximum clicks between Tuesday and Thursday. And second is about the banner position. And in this we can see the zeroth and the first position are having the maximum number of impressions and the maximum number of clicks. And from here we can just correlate it with the banner features, like if we visit any web page, so these can be the positions or the top positions which are always there. Like the ads, if we search something on Google and the first position there is some ad, so this might be the one which are shown maximum times and receive the maximum clicks. Okay, but there is if we look at the CTR of the banner position, so we find that the CTR for the seventh banner position was maximum. But this should not be very surprising because the impressions itself are very less for the seventh positions as compared to other positions. Okay, now next is this is also the clicks on based on the device type, and the maximum was for the first device type. Okay. Now, starting with the data processing and feature engineering. So, as I told, there are around 23 feature columns, and out of these, 9 were categorical. So, we know that categorical features cannot be used as it is in the model, and we need their numeric data types. So, we had to encode them, and the function we used, the technique was using a hash function. So, we implemented a lambda hash function for this for each column, and get to get the numerical encodes. And then there was a task to reduce the number of features for the cursor dimensionality. And we know that if the number of as the number of features increase or the dimension increase, so accuracy and the or precision of the model goes down. Then for this purpose, we had tested mutual information score, then principal component analysis, and we had also tried correlation metrics. But mutual information score was something which we could easily understand and correlate with the data, and then make some modifications in the data. So we tried some combinations for this. Combinations, we had also searched on the Kaggle discussion page of the competition. So from there we had got some information that we can make some changes. From there we got to know that yes, we can. That if device IP and device model and device ID are clubbed together, then it can form information of the user he is visiting. And similarly for other device information, we could make of the device model and device connection type. So consequently, this really helped in improving the overall precision and classification, and thus only the combinations of these features were kept, and individual features were dropped. And to further reduce the number of features, we dropped a feature like ID and R, which was just to identify that the position, but were not giving any help in classification. Okay, now for model training and testing and evaluation, as I told earlier, that we had split our data into 18 to 20, 18 to 20 ratio. So 80% for training and 20% for testing. And three models were used with hyperparameter tuning. For hyperparameter tuning, we used a randomized CV to get the best parameters. And first model was from the decision tree classifier, the second was from a random forest, and a third from the XGBoost. And out of these all these three, the best one was the XGBoost, with the better classifying from the ROC score, and better precision, which we check through the cross validation, k-fold cross validation. So here's a look at the uh, results. Like we can see the decision tree was around 79%, and ROC was of around 70. And for random forest, it was similar to decision tree, and the ROC was a little bit increased. Then XGBoost did well, and with the precision score of 80.2. 02%, and ROC AUC score of 73.80%. So here is the graph for the ROC AUC score. Okay, now the coming to the application part, since we know that CTR helps in getting the ads performance, so it is very important metric of evaluation. Uh, mm, uh, and with changes, if we could integrate it, if we had built a pipeline for this, then it would be a scalable model which could be used for every type of data set. But right now it is only restricted to the data set we are using. And if we could build a pipeline that converts every type of data set to the model to which the model can implement, then it will be of great importance to all the sponsor advertisers, and to target their end users. And from this they will be able to improve their performance. The advertisers will be able to improve the performance of the model, and the user will get a more related ads or personalized ads that he may be willing to visit. Thank you.
You walk
I
through
would
the
request the
slides.
panelists. Yeah.
So, pretty well presented. First of all, kudos to you guys. You have really structured the project well, I guess. To something. So one thing is like it is a very, I would say, a typical supervised learning problem where you have a structured data set, you have a target variable, and then you do feature engineering and try to get as good output as possible. So
Yeah.
you have done quite a lot of things that are correct, and I'm really impressed with that. So can you just go to the starting? Maybe we can walk through slide by slide. Actually, there were a few feedback points that I wanted to give you guys, and some things that I wanted to call out as well. So yeah, just we will go directly to that random sampling that you mentioned. Yeah.
Data collection.
Oh, yeah. So one of the things that I would suggest is this is something that you guys can look up later on as well. So instead of just selecting random entries, we select entries based on distribution, right? So what happens is you have a particular distribution of data, a normal distribution generally. And what if you just randomly select entries, it is very much possible कि जो तुमने data लिया है उसका distribution is quite different to the original main data set. Okay, so we try to keep the distribution as similar as possible while taking. So you did random sampling, that's good. This is something that you can look up in future. Ki, try to maintain that distribution as well of the data. So when you'll read more about it, then maybe you can get a very clear idea of what I'm actually talking about. यहाँ पे actually समझाना थोड़ा मुश्किल हो जाएगा, but this is something that you guys can, in the future implement it.
Okay.
And another thing is if we go ahead on visualizations.
Yeah.
So again, you have done a good job on visualization. So here I have one suggestion. Instead of directly putting snapshots of a Python generated chart, what you could have done is written this data in a CSV file and then created the charts in Excel. Because then it becomes much more presentable. The information is conveyed far too clearly. So for example, here the second chart, the hour of the day. Okay, here you have only 0, 5, 10, 15, 20, right? Excel could have given you a much better scale, a much better look, I would say. Sometimes when, so you guys in first years, you guys are first years, right?
Yeah.
Yeah, so basically जब तुम job में जाओगे करोगे, these are some of the things that your mentor or manager will continuously poke it. He'll continuously remind you, okay, do this, do this. So try to build a habit, and this is something for everyone which is on this call. If you're putting graphs, make it presentable, make it reader friendly. For example, एक बहुत simple से example हो जाएगा hour of the day. So you have hour_of_day. So in terms of coding, we are all engineers, chalta hai. But when you are presenting this kind of stuff, it should be like a very clear English hona chahiye, theek hai? Hour of the day. It shouldn't be a very codified format. So that is something. And I had a confusion can you go to the next slide? So again, same things for these as well. Yeah, next. So banner position. So here you are mentioning numbers, right? Maybe you could have put a snapshot of a website or web page where you can actually pinpoint the banner positions to us. तो मतलब हमारे लिए visualization के लिए काफी easy हो जाएगा. Okay, what position are you actually talking about? Okay. So that is one. And next. And yeah, for the device type, I'm not really sure ki, okay, 1, 2, 3, 4, 5, what do these actually mean? So maybe it could be like an Android device or iOS device or a Windows or something like that. So
Actually,
here,
in the data itself, it they did not mention about what type of device they were using.
okay,
They
you
were
didn't have
very
a data dictionary kind of thing, जहाँ पे मतलब,
no,
okay,
like
then
most of the
that's
thing.
fine.
Yeah.
That's fine then. That's fine. Can we go ahead? And guys, if you आपके भी जो questions है, just ask them. Okay, I'm going through that. मतलब doesn't mean you guys speak up later. And okay, for here, I'm really impressed by the fact that you are using some of the terms like curse of dimensionality or there was one of the terms like, yeah, mutual information scores and something. So just wanted to know that, have you guys also used VIF, variable information factor or something, some of those standard terms?
No.
Okay, then this is something that you can look up in the future. And yeah, here you mentioned that there were 9 categorical variables where you used a hash function. So just wanted to understand, can't we directly create these categorical variables into categories and then plug it in the model? You know, you have label encoders, you have one hot encoding on all those kinds of things. So did you explore those things as well, or मतलब directly hash function use किया था?
No, no. We actually I tried with the encoding, label encoding, but it was actually this was much more simpler and just it was for 2 lines we could get the same result. So we went with this one. Actually,
Okay.
for this encoding, for label encoding, first we had to train it, then test it, and then we had to get the final one. And but here we
I
using
mean,
just two
train
lines of
test.
hash.
How are you saying train and test? I mean, you have categories. Like for example, in a column you have 5 categories, so it will simply label it as 0, 1, 2, 3, 4. You have apple, mango, orange, banana, something like that. So वो बस एक number assign कर देगा उसे. That is label encoding, right?
Yeah, actually, in the I went through the documentation from there. From there, it was like we had to first train that it for that encoding.
Acha,
And
you're talking about the fit transform
yeah,
method?
yeah.
So, yeah, it is nothing. You simply call that fit transform function and pass in your particular column, and it will automatically do it for you. Basically, what with in a complex sense, it is like you have trained data, test data, right? So
Yeah.
you do a fit transform on trained data, and then you do a transform on test data.
Yes.
नहीं भी करते तो भी चलता है. So depending on the volume of the data. Yeah, okay. So one more thing. What was your total volume of data? मतलब how many rows you had, how many entries you had?
In total, it was around. Let me just get the right number.
Approx भी बता दो चलेगा. Million
Approx
entries, lakh
40
entries.
million. There were 40 million entries.
40 million. Okay. Acha, okay. And finally, you trained your model on 3 million entries.
3 million.
Okay. So you had considerable data. ठीक है. Okay. Can we move ahead? So here you created some combinations.
Like different more combinations were tried, but eventually they were like either reducing the mutual information score overall or just not helping in improvement. So these were the ones which I actually had.
Okay. So, okay, we can go ahead.
Hey, excuse me, I just had something to add here. So,
yeah, even I also have a question. So, before that.
so is there any mechanism which you are using to actually record the previous? I don't know if it's going to be against privacy policies or something, but is there any mechanism to actually note like use previous behavior of the user? Like I think just asking.
Yeah, actually, the other partner means the fourth year partner Suresh Bhaiya, he was trying on it to capture from the based on R wise of the means in which R a particular user is visiting, and what type of ads means in which R he's actually visiting, and just capture that sequence, but he was actually busy with that, and I could not actually make out about what was his plan, so we could not include that in our model.
Cool.
And uh, I don't remember. I remember reading a paper. I don't know. I wanted to know what features did you use? You mentioned few of them, position and things. Like, could you guide me on that? There's one specific thing that I'm looking.
Where?
The final, basically the final
What all
columns
features?
that are going into prediction. मतलब
Yes.
code में या कहीं पे you have a list of columns, and what do these columns signify? Or actually, before showing that, can you just go back to the last slide? Just one point I wanted to point out. Back. Previous slide, where you were creating the additional features. So here, what I'm seeing is like you have created a column device info, and here you are adding banner position, device model, and device connection type, right? So sometimes because all of these are numeric columns, so adding them won't create any problem. But at times, when you're creating a model with a business problem perspective, right? You have to solve a problem. So at that time, you need to take into consideration कि actually these numbers make sense or not. मतलब ठीक है, मैंने बना दिया model and it's good, and I find कि device info is actually a very important contributor, but I cannot sort of understand ना कि banner position plus device model plus connection type, इनमें से क्या important है मेरे लिए, right? It won't make sense. Banner position एक web page पे एक particular position है, device model एक model है, right? So there are generally two approaches. एक approach होता है where you go for the accuracy and you create any random feature. You don't really care whether that feature makes sense or not. And one is where accuracy is not important, but business explainability is important. And so this particular example where we are predicting where a particular ad will be clicked or not, it really becomes important that each and every column have a big business significance, whether this makes sense or not. So this is something to think about. And yeah, that's it for this one.
Yeah. So specifically, did you like take into account the ad relevancy to the website or any feature like that?
Actually, it is not involved right now. Like I said earlier, we were trying for the based on capturing the R performance of the user. Right now, it is not there. Actually,
Okay.
or also like there were many anonymous features. Like out of all these three, 9 were anonymous features from C1 and C14 to C21. So we could not actually get what these
What
anonymous
they were.
features. Yeah.
Okay. What each feature
What were
was?
the values? What were the values of these columns? Were they like binary or numerical?
Like they were in an integer format only, but they mean a very limited number of like they means like uh,
Yeah, like just
object
when.
there were object type only, but converted into integers, like
Okay, yeah. So just on a future note, like maybe when developing or doing any metrics about ad, it is important to know like what the user was thinking, why he came to this electronics page. So then they give ads about maybe certain electronic product that gets into account. I think that would be there in the feature set that was there, but it was anonymous, so it's all right.
Okay. I guess I had 1 or 2 points. Maybe we can quickly go ahead. So, okay, over here, when you're mentioning the matrices, I would expect, because it is a binary classification problem, having a confusion matrix is again quite important. Okay, so I don't think you guys had mentioned it, but because it is
Actually,
a
we had got a confusion matrix in our code, but it is not written here.
yeah, and I am actually viewing your presentation, so
Yeah.
at times it becomes important.
Uh,
So
I,
this is just a feedback which you can use to improve your slides. And
I had one more
so
point regarding the metrics part. Uh, can you just move to the next slide? So here, like you have mentioned the precision values, right? So I was just curious as to like, was this based on one experiment, or did you have like multiple experiments, or like how many experiments did you have, and converged to this value? Basically, I want to ask, did you average out your experiments to this value, or this is just based on one experiment
For precision,
or one run? Yeah, precision, or for
no
that matter,
precision in
any metric, not precision in specific, just any metric that you stated in this presentation.
no, they are all based on average values.
And what was that, like how many runs did you have?
How many? There were around 5 to 20. Like these are average of the cross validation scores of after the dividing the samples into 5 parts. Yeah.
Okay.
Just a clarification over here, adding to Nemath. Can you go on the previous slide? Just wanted to know the number of K in K fold. It's not. So what was
Actually,
the value of
5.
K?
It
5.
was 5.
Got it. So what you're doing is basically you're taking your training data, which is an 80-20 split again,
Yeah.
and then you are splitting that 80 into 5 parts,
Yeah.
using 4 for training at one point of time and testing it on the 5th part. And
Yeah.
you are basically doing this for all the parts, right? And
Yeah.
then on the next slide, you have mentioned their average scores for
Yeah.
the best model, for the
Yeah.
best decision tree. Okay. So you haven't mentioned the scores for the test data set, right?
Yeah, the scores
Like,
were better than these. Actually, they were around for that. Like I remember for the exhibit, it was 83%, and
on the
for
test.
training and test.
No. So with
Is this for
cross
test or
validation, this
trade?
is basically your training score. It's
Yeah.
cross validation is done on training data, as far as my understanding goes. So these scores on your that 20% wala data, या फिर are these scores on that 80% wala data? So this is the question.
These are on the test data scores.
Okay. Then yeah, I would have matlab, it would have been a bonus to just sort of first of all get the training scores as well. So matlab, we could have got a perspective on how the model is actually behaving, overfit or underfit or those kinds of things. And yeah,
Like for the
you
training, it
guys
was
have something to add over?
Sorry to interrupt again. I guess the time is already up. Can we just move on? To the next team, if that's fine with you.
Yeah. That's fine.
Okay. I would like to thank Team ML11. Now is the turn for the Team ML16 for the project on movie recommendation system with spoiler detection. You can go ahead, Team ML16.
Am I audible?
Yes, you're audible.
Is it visible?
Yes, it is visible.
Okay. Hello everyone, myself Saurav Kumar, and this is the headline of our today's talk, and I am presenting the recommendation system on behalf of our ML16 team. Now, oh, now this is the outline of our today's talk: introduction, then literature review for recommendation system, problem statement, proposed approach, result and model working, followed by references and some appendix. Now, coming to the introduction part, what is recommendation system? Basically, a recommendation system is an information filtering system, and here information can be anything like any product, item, or any movie recommendation or something. And here we focuses on movies only. Okay. Now, why we use recommendation system and where it is used? Basically, recommendation system is used when a user search something, then we recommend the similar things which matches with that means that user search. Okay. Now, this recommendation is basically nowadays used by the big giant company or small companies, Twitter, Facebook, or every means companies. Now, what is the goal of the recommendation system? Now, recommendation system is basically it recommend the product according to the customer choice. Now, coming to this literature review for recommendation system, we have done means lots of literature review towards this recommendation system, and I have just summarizes. Basically, this recommendation system is basically a 4 types like collaborative filtering. In collaborative filtering, suppose there are 5 users and 4 user buys some item, suppose I1, then suppose fifth user come, then it will automatically suggest that item to that user 5. Now there is an other variant like content based filtering. Here we can see content based filtering is similar in approach with classical machine learning technique. It needs a way to represent the item IJ and a user UI, right? And this way basically it combines user and item, and then it means based on the rating it predict the item. Now, there is another variant like a similarity-based filtering model, and this similarity-based filtering model is basically of 2 types like user-user similarity and item-item similarity. In the similarity-based model, we basically build a matrix like rows. In rows, all the users are there, and in columns, all our users are there. And we like type of similarity, we calculate the similarity matrix, and which has the highest similarity between the users. We recommend that product that user buy previously. Okay, and now same for the item similarity matrix. And we have also drive through this matrix factorization technique, and there are so many matrix factorization technique like singular value decomposition, probabilistic matrix factorization, non-negative matrix factorization, Bayesian probabilistic matrix factorization, and many more. Okay, now coming to our statement problem. Our statement problem is so simple, like we have to recommend the similar movies as per the user search, and this is our proposed approach. We basically build a UI, and from the UI, when a user type search a movie, then it will goes to the information dataset, and from the information dataset it will fetch the movies, and then it will display on the result, and along with it will also do the spoiler detection. Okay, now what we did actually in our model, basically we downloaded the data set from the Kaggle. This basically it is movie data set, and we have done some pre-processing because there are so many null values and so many means NaN values are there, so we have done initially some pre-processing. And basically this data set has approx 24 features. So like budget of the movie, release date of the movie, and home page or something like, but we have extracted only these 6 features, and we have worked only upon these 6 features because these features are relevant to predict the similar movies. And from the extracted feature we have done some cleaning because this feature has means contain some non means some numeric value, but we have convert them into a string. Okay, And now then we consolidate all the features. Like we have joined all the features like genre, keywords, and title, cast, director, and tagline. And then and after that we have fed this consolidated feature in the count vectorization. We have used this count vectorizer here. This is basically why we use, because most of the model accept the numeric value, so we have used this count vectorization. We have also gone through the hash vectorization, TF-ID vectorizer, but for the simplicity we have used count vectorization. Okay, in this factorization, what it basically does, it means it will converts like one hot encoding. It will convert all the means features into a form of 0 1, like. And this count vectorizer is based upon the bag of words model. So basically what he does, it does basically converts the text into numbers, converts the document to a fixed length vector of number, and discards all the information and order of the text, and just consider the occurrences of the word. Now I have taken some example how it works. Suppose I have created manually a document, like I have taken the genre of the movie, and here and I have created the object of the count vectorizer, and here we can see this is the output for this object, like action is at 0. This is 0 is not the number of occurrences. Here it is the index in that matrix, means and here is the final matrix. This is the count matrix we have got. Now when we got this count matrix, then okay, wait, yes, this is the example of we have taken from the medium.com. This is the example. Basically here about is not actually, this is actually logical, but this is actually logical, but in the practice here it is index. Okay, now we fed this count matrix in the similarity cosine similarity, and from the cosine similarity we get the similarity score for all the features. Okay, this is the how the cosine similarity works. Here is an example, and for details I have appended some slides in the appendix, and I'm not going to discuss here. Okay, and now this is the result and working of our model. This is the home page of our this model. Here user will enter the movie name, then this will here then all the details about the movie will be displayed, like what is the movie poster, and all the details of the cast, and the recommended similar movie to expect recommended. And what we conclude from this project, like we have built a model that suggests the similar movie according to user like, and also can take the review from the user. Here also we can, if you want to give the review, here we also give the click on the review, and it we can submit the review to the movie. Okay, now these are the some references. These first some references for the cosine similarity, and this is the count vectorizer, and it also includes the many vectorization methods. And thank you. And we will show the demo of the this model. Swasti, can you show the demo?
Yes, I'm sharing. I hope my screen is visible.
Yes, it is.
Okay, so this is our homepage where the user will come, so he can type any movie like Iron Man 2. So if he clicks on recommendation system, so since we have made all the static web pages for our project, but we can change it to it is loading, and it is taking all the similar movies from the API key, and it will show the recommended movies and some detail of this Iron Man 2. So just wait for a second. It's coming. So, like here, this is the title line of the movie, and this is the back path of the poster of the image of the movie which we have typed, and these are some basic details of the movies like rating or of the genre of which the movie is, and some small summary of the movie, and these are some cast details for the movies. So we have not shown much details about the cast because our whole project was static. If we have made dynamic, then we can also add some dynamic functionalities, like if you click on any caster, then we can get the details of the cast. So we have keep it simple, and these are some cast of the movies, and these are the movies which our model has recommended. So like Iron Man 3, Avengers, and these are the we have recommended the top 10 movies from our matrix which it has predicted. So these are the movies, and we can also make some functionalities, like if we click on this, then we can further go on this movie. So this we will do in future, but till now we have done all the static part. So this is for the recommendation part. And if we go back and search for any movie like Divergent, and if we go on review button, and then we will get all the reviews which a previously user have given, and these are their labels, whether they contain spoiler or not. So what happens is that we are running it on locally. So our spoiler model is not present in local system because it is used in size, and its metric is also in large in size, so we cannot run it locally. So what we have done, that if we give some review, then if the user click on post, then we have successfully stored their review. So we can further do the spoiler detection on the stored review, because we have our model, and whether the review contains spoiler or not, that is not the user thing to know. So we will do the spoiler detection in background. We have that model already done. So, but we have not integrated that model with this. In this, we have simply the recommendation system and the review part. So this is all about our model. If anyone have questions, then please ask.
Yeah, I have a question, Swastik. So, can you tell me about your spoiler recognition flow? Like, is it completely pre-trained one, or have you worked on it, or is it completely from somewhere else, like the model?
In spoiler detection, what we have, we have a IMDb data set, and so the data set basically contains all the reviews and whether it is contains a spoiler or not. So it is a more or like a supervised task. So we have divided this task into a LSTM model. So and it will simply take each do the tokenization of the word, and it will understand the meaning of each word. And when we have done the training of that model, it was overfitting, I guess. We get around 98 accuracy on training data set, but we are not getting much accuracy on testing data set, because the reviews are basically according to the users. So some reviews can contain spoiler, but their language is not very much according to the machine. So we are not getting much good accuracy in case of a spoiler detection.
Got it. So currently you're using a pre-trained one, right?
No, we are not using a pre-trained one. We have trained our own model, but
Okay,
it is
just the
over.
metrics. Got it. So, like, have you listed down some way, like, about your metrics, maybe for this recommendation system as well as a spoiler alert? Because I think I didn't find that in slides.
Yes, I have that matrix. Just wait a minute. So, can you share this window, Visual Code?
Here you can share.
Yeah, if it's not possible, then I think it's fine.
Swastik, you can share.
No, this is our directory. So this is cosine sim1.npz. So what we have done, that we have made the matrix, but we have stored it in compressed form. So we have not stored it in 1010 so that we can visualize it, but we have compressed it using some library which Saurabh have told already, and we have stored the compressed version of it.
Yes, actually, if you want, I can show this matrix in my notebook, Jupyter notebook.
Yeah, if it's up and running, then fine. But if it'll take time, then I think we'll continue with other questions.
Okay, if you want, I can show.
So yeah, maybe you can set it up till maybe others can ask questions till then.
So I have a question. In your slide, you mentioned that you are using bag of words at a stage. Uh, like, could you meanwhile open up your slides? I think you mentioned somewhere that you are using bag of words.
Yes.
So are you like handling it, like removing all the stop words from it, like the,
No.
on?
Yes,
Okay.
means we have explored this bag of words because in the count vectorization there is so many argument we can explicitly give to this model. Like suppose we own create a stop words like in, we don't want in, a, the, then we can explicitly give to the model means. And how this work we have visited means how this count vectorization is works. Like this count vectorization is based on this bag of words model. We are converting text into a fixed number and fixed length vector of number, something like.
Actually, when maybe going for a very large documents, bag of words has some instability issues. Maybe like it
Yes.
completely ignore grammar. So, is there any future scope that you will be using something else instead of this, or?
Yes, instead of this, we can use means in the recent research. So means TF-ID vectorization is used. Means these are the advanced version of this count vectorization, and there is also hash vectorization methods. And so means so many methods has been developed in recent years. So we can use means we didn't explore means like other models. We have explored like hash vectorization, TF-ID vectorization, and this count vectorization.
Okay, great. So overall, your presentation seems to be very well structured. Uh, that is something nice. And this is something to all the teams that I've observed. You need to, everybody who are here needs to work on their way how you present code. At least code snippet should be present in a separate, like in a different way that it sees. The font should be different or something else. And if you're sharing a bigger section of your code, have the comments, have it commented well as well.
Yeah, and more than code, I think if you have a pseudo code, that would be even better. Like in your slides as itself. Yeah.
So just a small suggestion, like you mentioned count vectorizer, you have used count vectorizer over here, right?
Yes.
So count vectorizer, TF-IDF, these are some of the very classical models that we generally use. Basically statistical models. We use a log function and try to get the importance of every word, and then we build a model around it. So like other teams, maybe you could have explored a much more sophisticated version like transformers. So what you're doing here is basically a part of it is something which we call as topic modeling. Okay, so you have set of words and you try to create a topic out of it. Basically group words meaning similarly, which means have a similar meaning or which convey a similar context. So there are libraries like bird topic and topic modeling, if I'm remembering it correctly. So there are these kinds of libraries which could give you a much better result with much less effort, because then you wouldn't have to worry about stop words or n-grams or anything like that. So this is worth something exploring. And other than that, even if you are working on text, working with text, clearing data and something. So I don't know, has any of you heard of it, but there is a library called Spacey. So yeah, so it is a very like an advanced version of NLTK. So NLTK is like the classical version or classical library used for text, anything related to text. And Spacey is like just take it to the next level. So you guys, this is a general advice for everyone. You can explore Spacey and topic modeling libraries, transformers. So you will get a better understanding key how to approach a problem, or like Shavez mentioned, there are some issues with bag of words. Bag of words is a very limited thing. मतलब नया word आ गया जो उसमें नहीं है, it will create a problem. So, but that is not the case with transformer models, because they have a very exhaustive vocabulary जिसके ऊपर वो train हुए हैं. So these are some things that are worth exploring, and maybe for the organizers going forward जब तुम अगले editions करोगे, तो these are some of the underlying things that you can point out to all the participants. You guys can explore this. So that is something that I just wanted to mention in general.
Yes, actually, yes. Basically, we had actually implemented this recommendation system model with the surprise model. If you heard about, means in Python there is a separate module called surprise, and but we have also gone through this NLTK or lemmatization stemming something, and from there basically if we predict rating, then I think those models will be beneficial. But if you predict the similar movies, then means we go means this basically this if we use this model, then this predict the same movies as Google means recommend. That's why we have built actually 4 to 5 model, and this model
Yes, we have explored some of the newly recent libraries like Surprise. In that we have many new functions for direct recommendation system, but we are not getting much more similar results. So
Google
we have
predict.
tried different versions, and in this algorithm we got some similar result to the Google. So we have implemented this algorithm. We have explored many other algorithms also, but we are not getting pretty good results. So we have not used that approaches.
Sorry to interrupt, but we have gone over time again. So can we wrap this up and move on to the next team with your permission?
Yeah, just one thing. One of the guys were putting up that metrics, right? So is it ready, or then, or we can skip it?
No, it is ready. Means wait.
I just wanted to take a quick glance at it.
Yes. Wait, I'm sharing again.
Nemath, you have also had a question, right?
Yeah, same thing. I just wanted to have a look at the metrics.
Is it visible?
Yeah.
These are the cosine similarity matrix. This one. And here we are saving this cosine similarity matrix.
So how are you using cosine similarity? I mean, you calculated it, that's good, but iska use kya hai?
Use, yes. Here, suppose a user will enter the movie name like Iron Man. Then we have created a function from this movie name. First, we get the movie index from our data set, right? Here, movie index is 68. Now, from the movie index, we basically here we can see what I have done. Basically, we will access the row corresponding to the movie in the similarity matrix, and we will get the similarity score of all the movies from the current movie. And basically, we enumerate and we make the pair.
So what you're doing is basically once you have identified a movie, so you have kind of created a data set. You have indexed the similarity score for all the movies, and then you're directly get. Okay, got it.
And we are taking the top 10 means highest similarity movie.
But then the problem with this is it works, but this is not a metric for a model. It is a scoring methodology that you're using to sort of get other things together, right? How do I evaluate whether this model is working very good?
Yes, that's
this model is working average. So is there a metric? Is there a number?
No, actually,
this is the score of the model.
Actually, we didn't implement it based on ratings. We just implemented means recommend the movie. So means we can check through means Google movie reviews. We have checked this way.
your basic aim with this model is, अगर मेरे पास Iron Man movie है, तो get a list of movies which are related
Yes, sorry, you are not
to.
audible.
You are using Larry. How is the model performing?
Your
Is it
performance of your model.
how do I
Yes,
judge that
actually
this
we
model is
didn't
performing
implement
good?
it.
Yeah,
Means,
there is a model which can perform better.
better. Yes, yes. We didn't implement it. Means like accuracy or something. We direct means this means we can predict the means we can recommend the movie directly. And find the similar movie we means it is means performing better or not, means we have checked through the other recommendation models like what the Google use.
Do you have any accuracy test or validation accuracy or anything
No,
around
we
that?
have we didn't split in test on validation, test and train. Sorry.
So like how are you evaluating that your model is doing fine? So maybe like on the first attempt itself you have your model ready, and because you don't have a parameter to judge like how good the model actually it might already be giving you recommendations, right? So how are you like doing that part?
Actually I means we didn't get any approach, means how like we can evaluate our model something.
So those
So
two
to
papers that you stated at the end, didn't they
yes,
have something they should be having, I
no
guess?
they those papers about cosine similarity and count vectorization methods, means how they actually used in means we use generally.
Okay, okay, they were not about
Yes,
movie recommendations. Okay,
movie
my bad.
recommendation. Yes, yes.
Okay, I think maybe check it out once again if they have any metrics by which they evaluate a whole
Yes,
model. But
yes, there are so many recommendation movies which predict the rating. Then in that case, we can predict the accuracy, training accuracy, validation accuracy. But in this case, we predict the movie name, which is similar to the search. So means
So, at, we need to know how your model performs. So, can you do some basic tests and let us know by end of day today?
sorry, you are not audible. Hello.
Hello, hello.
Yes, yes.
You're like, as far as I can see that, do you have any test labels as of now so that you can
No.
start a test currently of around 100 tests of movies name things around that? At least we have a
Means
percentage.
taste. We don't have any taste. Means like we have the movie data set here.
Shavez, I think
What
we can
I
leave this
like,
out.
yes.
It would take time, and I don't think it is really worth pursuing it right now.
I think we, yeah, okay, definitely. Let's move on ahead.
Just one closing question. Just one closing question. So you're getting a cosine score, right? So for cosine score, you are putting in a vector. How are you getting those vectors? What are you using to optimize the algorithm to get those vectors?
Which one? Those this cosine matrix.
Cosine के लिए जो तुमने input vector डाला, वो vector कहाँ से निकाल रहे हो?
Those vectors I have means from I have extracted from the features. First we
Count
extracted.
vectorization.
Yes, yes, yes.
Okay,
Count
so
vectorization.
you are basically directly doing a count vectorization. Okay.
Yes, yes. We have yes. This is.
Okay. ठीक है.
We have convert the feature into the count matrix. Count vectorization.
Vishnu, I think we can move on to the next one.
Okay, yeah, fine. So thank you, Team ML6. And now I'd like to call upon Team MISC1 for their project on Smart Gallery. So you have the stage now, you can start your presentation.
Okay, my name is Abhishek and I'm sharing the content. Is it visible?
Yes.
Yeah,
Yes,
yeah, visible.
Okay, so good evening everyone. My name is Abhishek Dhangar and we are team MISC1.
and presenting our project on Smart Gallery app, which is based on ML and AI and app development. This app is a photo gallery app. It organizes your photos, helps you find them in easier way by allowing you to search photos using words in a way such that picture with maximum similarity with search text appears on the top of the image grid.
The tasks that we have completed for this project include generation of image tags, pre-processing of text, comparing text and tags vectors, upload images to Firebase storage, storing tags and image links in Firestore. For the tech stack, we have used Flask for the backend, Flutter for the frontend, and Firebase as the database. This is the activity diagram for our app. The user first needs to sign in to our app. Once signed in, the app accesses the images in the user device. Then the user can upload the images for processing or search the already processed images. Images are uploaded to an API which then generates relevant tags for the images using VGG image classification model. We are using the VGG19 model. The images are then uploaded to Firebase cloud storage. The image links and tags are stored in Firestore. On searching, the search API is called, which cleans the text and matches the keyword with the tag strings in Firestore using string matching. Upon proper matching, we return the corresponding image links to Flutter to be displayed.
Once images are uploaded, we have to classify images. First of all, what is image classification? Image classification is a process of putting tags or labels on image. We have used here pretend VGG19 image model to classify images. VGG19 is a convolutional neural network that is 19 layers deep. We have used a pretend version of the network trained on more than 1 million images from large ImageNet dataset. The pre-trained network can classify images into 1,000 object categories. So as we get the image, it will first be converted to binary form. Then VGG19 will give the image tags for that image. This is the structure of VGG19. When users search for the text, we have to clean the text. So we have performed the following operations with NLTK on search text. First, tokenize, that is to split string of text to arrays of words. Second, lemmatize, convert words to its base form. For example, bags to bag, eating to eat, etc. Remove stop words. Stop word like a and the, is, am, are, word should, etc. are removed.
To compare the tags and the search text, we are using cosine similarity. Before using that, we are using the word2vec model to generate word embeddings. Word2vec creates vector that are distributed numerical representations of word features such as context of individual words. Then we compared the clean searched text with all the image tags vectors and calculated the cosine similarity for all of them. The tags vector with cosine similarity greater than the fixed threshold will be displayed in the image grid. Also, like they will be arranged in the descending order of their similarity values.
For database, we are using the Firebase. Firebase is a Google-backed application development software that enables developers to develop iOS, Android, and web apps. The platform provides developers an API that allows app data to synchronize across clients and stored on Firebase Cloud. In our case, Firebase is connected to both Flutter frontend as well as to the Python server. Its cloud storage service is useful for storing user images. Using Firebase enabled users to connect to our app directly through their Google account.
So using Firebase storage had its own advantages. Like imaged in our case are accessed by the app, like the front end as well as the server. Hence, we are storing using cloud storage. Now, cloud storage allows access to images from both server side and client side. Hence, data exchange becomes efficient as payload size decreases significantly using image links. It also allows images to be associated with their rightful users in a secure manner. Firestore database stores links to these images along with their tags. The image links from Google Store API allows images to be then displayed in the image grid directly from the Google Storage bucket in Flutter.
Now authenticating users through Firebase. For user registration, we are using authentication feature of Firebase, which allows an app to securely save user data in the cloud and provide the same personalized experience across all the users' device. Firebase authentication provides backend services, easy to use SDKs, and ready-made UI libraries to authenticate users to our app. From various options available, we are using Google sign-in option to authenticate our users.
Okay, now moving to the front-end development, the user interface is created using Flutter. So after the user installs the app, this intro slider page will appear. This page will help the user to have a brief overview of how the app works. There are 3 simple steps. The first one is sign up, then upload your image, then we can start searching the image. So on clicking the get started button in the app intro slider page, the app will direct user to this page. This is the sign up page. So here we have a sign in with the Google option. So next one. So after clicking that, will the user can choose from his one of the Google email ID to signing into our app. So after signing in, the home page will appear. Okay, this is the home page. So we have the image upload button and image search button. So like after the user will first time when he will install the app is to upload all his files to our database. So that is a one time process. Like next time if he'll uninstall and install, no need to do this thing again. So after uploading the images, the user can start searching. So we have given an example here. So like if we'll search cat here, so will be directed to the search result page. So this will be something like this.
Thank you.
Here's a small demonstration of the app.
Adip.
Adip will present.
So I present from Visor. Slow.
Okay.
Is it visible?
Yeah, it is visible.
I can't present only this Visor application. Continue.
Okay. So this is the our app icon, Smart Gallery. On opening the app, these intro slider appears. Sign up, upload, and search. And this is the sign up page. We can sign in through the Google account. And here we have 2 buttons, search button and upload button. So let's search for the cat. So here are the search results.
Thank you.
Thank you.
Could I proceed? Absolutely.
Yes.
Yes.
Yes, yes.
Yeah. So, seeing from a point of view of a project, all round, I like that you use Firebase. It should have provided. Okay. So one question: you said you use VGG19. What was the
Yes.
reason of using this, and what else was there in your attention?
For models, we also found something called ResNet and Inception. Inception is from Google. Inception was classifying into one single class, and we needed more than one class, so we didn't use Inception. As for ResNet, it was a little bit heavier than like it, it was a little less efficient than VGG19, so we went ahead with VGG19.
Okay. And on top of VGG19, did you do any extra transfer type learning, or you directly use VGG19?
No, we directly used the VGG19 because we didn't need to add any other classes or anything like that. We don't know how many classes we'll get anyway, so we just use the ImageNet data set for VGG19 from
Okay.
VGG19.
Yeah. And on the to mark similar images, you use cosine similarity, right?
I'm
Shavez, your
sorry,
voice
sir,
is
you're
quite
not
low.
audible.
Yeah, okay. I should be careful about that. Yeah, or to mark the similarity, you use cosine similarity, right? How, like,
Yes.
more closer to one.
Yeah.
Okay. Anything
Yes.
on that exploration
Uh,
side?
Actually, for that we use the word-to-vec model, which basically converted our strings into vectors, and we use the corpus of Google News data set, and then using that, we are able to convert our words strings into vectors. Then we then used cosine similarity to find the cosine similarity to uh, find the similarity between the
Similarity.
two, yeah, similarity between the two vectors that were then produced.
Yeah, okay. So, like, I'm aware about the purpose. I think, is there any other option apart from using cosine similarity, or
We could have used like
it is
Euclidean
popular as
Euclidean distance between the two vectors, or path distance. I don't exactly remember the names, but yeah, there were other similarities there, but we went ahead with cosine
yeah,
similarity.
yeah, it's fine because it's already being used around 80-90% of things. I just wanted to know this like
Yes.
that.
Just wanted to confirm a small thing. So, since you have created a mobile app, did you consider using onboard uh, computation instead of sending it to a server?
Like we also had this option of TensorFlow Lite, but like in the beginning we were two teams, so we like divided, like one TensorFlow Lite and one with API kind of thing. Yeah.
Okay.
So yeah.
So yeah, you did so did you consider, or maybe what kind of progress did you make in that direction? Not necessarily completing it, but just wanted your perspective, or how did you approach going for onboard computing, because that is something which is quite hot right now, as
Actually, we didn't go in that because, like, when we first started making it, we added the flask, and then when we like were showing, then we were told, "Give since like we already made the flask, we were like given the green light to go ahead with that." So we didn't explore the TensorFlow Lite because, like I said, there were two teams, and it's like both of us were divided into, like, one could do the flask and one
got
can
it.
do the TensorFlow Lite. So we didn't proceed in that direction. So yeah, we proceeded with
Yeah,
flask
no
and
issues, no
Firebase.
issues. Got it.
This is a question to panelists. how do you think what would be the metric features of that? Because I think uh, the app was fast enough because it was already using internet, so we cannot really evaluate the response time to get the result. Uh, any questions if you have on this point?
So you want to sort of question the efficiency part, like
Because the model is pretty standard and we know what it does.
So maybe we can look at the inference time, maybe like overall,
But
but
yes,
that would again be based because this is a pre-trained model. It would be a good inference time, I think. So
exactly, and even
on the
we don't
on
know
the
the chain.
exactly. So on the ML side, because it was not the main focus of the project, I guess. So I think there is no clear. I mean, there is no direct metrics in this problem statement.
Yeah, exactly. On the ML side, I'm also not very sure. Overall, the project seemed good because they used right things to do right stuff. Uh, in the framework side, at least.
Also, you were using like the 1,000 classes ImageNet data set, right? Or was it like a tiny ImageNet?
No, not all 1,000 classes. We just like upload the entire thing. Yeah.
Got it. Also, in future, if you plan something on onboard, like you told, you can go ahead with TensorFlow Lite. Also, there is a library known as QKeras, which helps you in this sort of things like making it hardware efficient. So maybe if you are
Okay.
planning ahead in the future, you can just give it a look.
Yes, yes, sir. Sure, sir.
No, 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 not
Not sir,
sir.
please,
Yeah,
please.
yeah, just
भैया
2 or 3 years. What does it mean?
यार,
4 months.
मुझे जहाँ तक याद आता है, हमारी बैच और तुम्हारी बैच ने क्लियर किया था कि सर और नहीं आएगा. कहाँ से आ रहा है सर ये?
Exactly.
academy से आ रहा है ना. The professors, I think TS को भी हम बुला देते हैं कभी-कभी.
ये का तो फिर भी समझ में आता है,
भैया
but we made sure during our time कि कोई भी सर मैडम कुछ ना आए. How this is a question to all the current 4th years and 3rd years. How is this coming in?
Can you share your screen again? I want to see that data flow graph. Probably just...
Okay. Abhishek.
Yes.
Activity diagram.
हाँ, activity type.
Okay, I will share.
So here I wanted to question something like how are you going about searching keywords? Is it like a only 100% match, or are you using some kind of algorithm to do a partial match or something like that?
Sir, actually, we.
Sir, nahi.
No, sorry, Bhaiya. Actually, what was I gonna say? We were currently we have put it like a threshold value of 0.5 because like 0 to 1.
So how are you matching
Maintains.
the words? For
Actually,
example, I'll give you an example. So there are two words, CAT, cat, and CPT. Okay, so I'm replacing the word A with P. So is it like a word-to-word comparison? C to C match हुआ 1 point, A to P not matched, so 0. T to T match हुआ तो 1 point. So you have 2/3, 66% match rate. Are we going in that direction?
No,
No.
actually, it works with the meanings of the words. And then, yeah, you were saying.
Yeah. Like we are getting here that keyword vector, and we have tags vector with us in our Firebase. So basically, it will match with number of words that are similar in both of the vectors. So it will give us 2 vector, and that cosine similarity, it will give some similarity value.
It also
And
works
then
with the meanings of the word, like synonyms, not
If I'm
exactly
remembering
similar.
correctly, word-to-vec is based on bag of words model, right? So basically you're converting every word into an n-dimensional vector where So are you converting the entire sentence or into one vector, or is it like every word is being converted into a vector?
No, one
And
sentence, one vector.
yeah.
One string into one vector.
Okay, got it.
Okay, so how does that perform when I'm trying to look for two objects in one search? Like I say,
Sir?
You are
Malick,
not
audible.
audible.
how will, like, if you are using the whole sentence to map to a vector, like can this app search for two things in a picture, like in one search query?
Yeah.
Yes, we
Yeah, yeah.
can, like if we write cat and bicycle, so it shall give similarity to both the tag list that has cat as well as bicycle, because it will map meanings and find a similarity. Like I said, currently the threshold is kept to 0.5, but actually we will have to work a little bit on that, like maintaining a threshold, because even with like the classes that are given for certain images, we don't have all the normal words, right? So some words are not mapped correctly either, so we need to work on that, like defining a threshold for the after the what to vec gives the similarity parameters.
Okay, so
And
this
have you have just small thing? Have you created some kind of table which puts down the numbers, like how it is performing, what are the match rates, and false match rates, positive match rates, anything something like that?
No, sir, we went ahead with the pre-trained stuff only.
No, pre-trained, that is
No.
fine. That is fine. That is not an
Uh-huh.
issue. Just on this match part, or maybe overall some kind of metric, how do you evaluate what I'm doing is actually a good? Okay, cat search या cat मिल गया, that is good. But that in 1,000 categories, if you pass that image through a BGG net, if there is a slightly confusing image, for example, let's say कोई एक leopard print वाला mat है, ठीक है? You have a rug जो बोलते हैं ना, and if you pass that, there is a good chance it can be classified as a cat. At the same time, it is a rug. So how do you evaluate performances for these kinds of situations? Matlab, have you even evaluated, first of all? And if yes, so are there any fixes or compromises that you're doing over there?
No, sir, we haven't done the evaluation kind of thing with the ML models. We created like simple models that works, and then we had to also create the web application. So the models are basically just like we created without much matrix and evaluation.
Got it. So
Like
yeah,
we,
that would be a point of suggestion. Even if you build a simple model, try to get some kind of basic understanding, like what are the limits of my model. So suppose tomorrow you are deploying this particular model somewhere, so you should be able to define the boundaries. मतलब मेरा मॉडल इतने तक मतलब बहुत अच्छे से चल जाएगा, इसके बाहर थोड़ा स्ट्रगल करेगा. You need to have that kind of points when you in your documentation, when you particularly productionize a model or something like that. So that is something that you can work on in the future.
yes, actually there are many more stuff to like explore in the project. It had quite a lot of stuff to do. So there are things that we would want to explore more
Right.
further in this entire thing.
Okay, guys, you have any other questions?
I have one question. Just a minute. Okay, so if suppose there is a dog and a cat and a cycle, okay, so you are in the same image, so you are generating three labels of that, okay, and then you are making all these three into one vector, or these are three separate vectors?
One vector.
One vector. So now
Yeah.
suppose if I change the order, the query has a different order, or cycle a dog and then a cat, that would be the transformer would interpret as a different vector, or that will be nearly the same vector,
Uh,
because is the order
Nearly.
relevant in your searches?
no, no, no. That
No.
order will not matter because we are using that cosine similarity, and it will not see the order. It will see the similar words in both the vector, and
Yeah.
according to that,
Even
it
in,
will.
like, once you are embedding those three words into a vector, now you are in the vector space, and in that vector space you are using cosine similarity. That is fine. uh,
Okay.
how are you going to that vector space? Like, I gave you three words: a dog, cycle, and a cat. Now, how are you going in the vector space? I want to check if it is symmetric in order or not.
Uh, ac- Actually, we are using something called smooth inverse frequency to find the using
Sorry,
that
I could
to
not hear.
smooth inverse frequency.
Smooth inverse
SIF SIF.
encoder. Because are you like able to visualize the? It's a codec. Okay. Are you able to visualize my question? What I'm asking?
Yes, kind of like. Are you asking about? Okay, are you like asking about if like having a certain order will have any
Yes.
effect on
Will
the
vector.
I
That is
suppose it will not have effect, but the frequency rather will have an effect on the frequency of words will have effect on the word vector embedded.
but if
It
cat
will.
is there two times, it will be not the thing that I'm asking. Maybe if suppose I query as a cat space dog, and then I
Actually,
do a different query, a dog space cat, they will be marked as a different vector. I'm asking this because I think you have used a patent model, but I'm not sure about your encoder. That's why.
Okay, that I don't know because the thing we are using is called smooth inverse frequency, which uses the frequency of the word. So I do understand the frequency will affect, but I don't know if the order will affect or not.
I'll check that out. SIF you mentioned, right? Okay. Even I have to check that out. Okay.
actually, you guys are using word to vec to get that vectors, right? So word to vec
Yes.
generally considers frequency of words in the sentence,
Yes.
and it doesn't actually use the sequence of the words कि कौन सा पहले आया कौन सा बाद में आया.
हाँ हाँ वही तो वही मतलब फ्रीक्वेंसी यूज होता है बट ऑर्डर शायद यूज नहीं होता.
You might be using bag of words, right? Bag of words is what?
नहीं हमने इससे we have used this Google News
नहीं.
Where is it?
When you yes, you use the corpus Google News, that is not an issue. But when you call the word to vec function, जब तुम actually convert करते हो, right? तो जो तुम्हारा bag of words होगा basically उस corpus पे बना हुआ होगा. That is the point.
That I don't exactly know that's what it is though. It's something called keyed vectors. It's one sec. I don't exactly know that.
Yeah, no issues. I was actually telling you. So word to vec, one of the मतलब major problems is word to vec doesn't take context into account. It just takes the word frequencies, word importance, those kind of things into account. So I was giving answer to Chavez's question as well. What is happening?
Yeah, I was like, I got confused on that which dimension was mapped to which word.
Because you mentioned now you use the Google corpus. So होता क्या है? When you train that entire corpus, every word gets a fixed score. Okay, and that score is kind of a log function. of its frequency upon all the words frequency, average frequency, something like that. I'm not exactly remembering the exact formulation, but after doing that, every word in the corpus gets a fixed score, and that score is basically used to get the score of a sentence that you pass in the word model. So that's how it works.
Okay. Okay.
Were those all the questions?
No, I'm good.
Yeah, me too.
Okay, fine then. Those were all the teams today. So I once again thank the panelists for their time and teams for their efforts.